small when we're not at all. And even giants need someone to land on when they fall. I'm trying to stand tall. Stay with me. I'm waking up like taking all my fears away with you.
Oh, alright, it's time for math. Okay, so first things first, I just wanted to go over the SAT math section a little bit, because I think it's important to know what you're getting into, particularly if you're just starting it. So, in the SAT math section, a large majority of the test is going to be multiple choice, but there are some grid questions where you have to come up with the answer that's not multiple choice, and you have anywhere between 1 in 1,000 or a fraction or a decimal that you can enter in as your answer. There's also a calculator portion and a no calculator portion. Now, it's really important to realize that for the calculator portion, you really don't need your calculator for 99% of the problems. On the test, I probably used the calculator for 2, maybe 3 problems. The rest of them, you're honestly better off without it. So that's pretty nice to keep in mind. In the test itself, there are 3 major areas that we'll be going over. I prepared a lot of problems for them, for each specific topic that they'll be covering. And each of these 3 sections will be approximately 30% of the test. And then this last additional topics in math is just geometry, some basic trigonometry, sine, cosine, and parallel lines, so things of that nature. Alright, so the SAT math test doesn't actually cover a huge variety in terms of what math you need to know. It's more important that you realize that the math test is going to present it in different and interesting ways. The whole part about conceptual understanding just means that you have to understand when to use which concept. And that's something that you only really get with time. After this video, you'll understand all of the concepts that you need for the test. It's on you, though, to look at each and every problem and see which concept you need to use and how you need to use it. Because it's different on every single test. And that only comes with taking more practice tests. So, you'll get it the farther you go. Yeah, so calculators, they say, again, however, the calculator is, like any tool, only as smart as the person using it. The math test includes some questions where it's better not to use a calculator, even if you're allowed to. It's really important to not get lost doing equations like 7 times 3 on your calculator, just to make sure, because you just begin to run out of time, and it's really taking time away from where it could be better spent. Because for a lot of people, just figuring out how to solve the questions takes quite a bit of time, especially for some of the harder ones. Yeah, so the whole grid-in section, I'd strongly recommend just using fractions the entire time, just because when you do decimals, there might be some problems with roundings, things like that. So I personally always use fractions. Other than that, there's not much to say about that. Alright, well, if we're done with that section, then let's get right into it. Okay, so scroll up to the top. The first section is called Heart of Algebra, so it's all about algebra, problem solving, and figuring out how to create and solve some pretty simple linear equations. So, the first topic that they ask you to cover: create, solve, or interpret a linear expression or equation in one variable. Alright? All that a linear expression or equation is you have x, and that's it. It might be times something, it might have a 2 in front, it might be divided by 3, you might have plus something. but this x will never have an exponent next to it. So nothing other than 1. If it's squared, it's not a linear expression. So that's how you can really just immediately recognize it. If you just have x, maybe it's multiplied by something, maybe it's divided, maybe it's added to something. It's a linear expression or equation. Alright, so let's just try a couple of these ones. These are pretty simple ones. You should be able to do them pretty quickly. Let me just copy and paste. What the? Oh, let me try something though. Alright, this will work. There we go. So, this question, pretty simple. If x minus 1 is, oh, it's actually pretty hard for me to click on this because I have a huge black spot on the screen because it's cracked. Oh, it's because I have press place image. Silly me. Okay. Pretty simple equation to start with. If x minus 1 over 3 equals k, and k equals 3, what is the value of x? Alright, so pretty simple. You see this, you know that you just have to plug it into this equation. X minus 1 over 3 equals 3. Now you're looking to isolate this x because it's asking for that value. X minus 1 equals 9, and x equals 10. So the answer is D. So, as you can see, this particular section shouldn't be that hard. Let's try another one. Alright. Let's do this. There we go. Alright. This is where we get to the creating part instead of the solving. So you see that it's just a line in a coordinate plane. Has a slope of 1 over 7. There's a pretty simple equation for linear equations that you need to know for this test. Y equals mx plus b. Most of you should already know this. This m is the slope of the line. This b is the number of the y-intercept. So they've already given you the slope, and they say that it passes through the origin. For those of you who don't know, the origin is 0, 0, just the center of the coordinate plane, right there. And we know it has a slope of 1 over 7. So y equals 1 over 7. As I said, m is the slope plus b. And now, in order to figure out what b is, we just need to plug in this point. So we know that the y-coordinate is 0, and the x-coordinate is 0. So plug in both of those. And we get 0 equals 0 plus b, which means that b is 0. Now we know that our equation is just y equals 1 over 7x. And so we look at all of these. If we plug in 0 for x, then this entire thing is just going to be 0. Plug in 1, then it's just going to be 1 times 1 over 7, which is just 1 over 7. If we plug in 7, 7 over 7 is just going to equal 1. So that's not 7. But if we plug in 14, 1 over 7 times 14 equals 2. So our answer is 14, 2. This one right here. So it's important to know this equation, y equals mx plus b, because that's where the create a linear equation is going to come into play. Alright, so a bit harder, but still shouldn't be too bad. Now let's go on to the next one. Just another pretty simple solving equation. and we get 16 plus 4x equals 10 more than 14. All that is 14 plus 10. It's important to not get caught up in the wording. What is the value of 8x? So what we're going to do, we're going to get 16 plus 4x equals 24. And now we're going to get 4x equals 8. Alright, so I'm going to show you what you would normally do and something that's a little bit of a time save. Just for people who are trying to speed through the test a little bit. If you feel like you're running short on time, you don't have to do it. It's not too big of a time save, but for similar problems, it could be a bigger one. So it's important to know, just to have in your toolkit, I suppose. X equals 2, so 8 times 2 equals 16. Alright, this is how you would normally solve it, and you get 16. Now, the bit of a time save I was talking about is once you get to this step, right, you should realize that you're not looking for x, you're looking for 8x. Is there any way you can get from 4x to 8x a bit quicker than going to x equals 2 and then multiplying it by 8? You could just multiply both sides of this equation by 2, and you get 8x equals 16 immediately. For this particular equation, it wasn't that big of a time save, but if you were to have like 8x plus 16 and like 4x plus 8 here equals 8, you could have actually saved a lot of time just doing this, probably a solid 30 seconds, where you wouldn't have had to divide by 4 or subtract 8 and then divide by 4, plug it over here, multiply by 8, and then add 16. So, you know, just a little 10-15 second time save. So it's important to keep that in mind. Know what you're looking for when you're solving the problem. It's really important to know, because the SAT tries to trick you with stuff like that as well. Alright, let's move on to the next problem. And here we have a bit of a more interesting one. An absolute value problem. Alright, let's place that down. For what value of n is the absolute value of n minus 1 plus 1 equal to 0? Alright, now we're going to subtract 1 from both sides, because whenever we have an absolute value sign, we want to isolate this entire absolute value so that we can get rid of it. So we subtract 1 from both sides. We get n minus 1 equals negative 1. Now, this is where knowledge about what absolute values are comes into play. Absolute value is the distance from 0, right? So if you have something like negative 1, its distance from 0 is just 1. The same distance that 1 has from 0 as well. All that an absolute value does is turn negative numbers into positive numbers, and positive numbers stay as positive numbers, and 0 obviously stays the same. So, when we're doing this problem, we should see, as soon as we see that the absolute value sign equals a negative number, we should know immediately there is no such value for n. Right? Now let's say it was a positive number. Let's say it was just positive 1, and this original equation was the absolute value of n minus 1 instead. Then what we would want to do is do n minus 1 equals plus or minus 1. So we get rid of the absolute value on the left, and we add a plus or minus in front of the right value. Now we can separate it into two equations. N minus 1 equals 1, and n minus 1 equals negative 1. So we get n equals 2, and n equals 0. Let me just make sure I'm recording. It'd be very awkward if I wasn't recording. Okay, yeah. and these are your two answers if it were to be n equals 1. But because we had it equal to a negative number, there is just no such value. Now let's go over, I believe, one last one for this topic. And then we'll move on to the next one, because this topic, it's pretty broad, but it covers a large section of the test, so it's pretty important to know. That's why we had so many questions on it. Which of the following air temperatures will be the speed of sound, or will the speed of sound wave be closest to 1,000 feet per second? So we want A, the speed of a sound wave, to be pretty much as close to 1,000 as we can. So for right now, we'll set it at 1,000 equals 1,052 plus 1.08 t. Subtract 1,052 from both sides, just get negative 52 equals 1.08 t. And we're solving for t, so now we're just going to divide both sides by 1.08. Calculator. Oh, I thought Google had a calculator. Negative 52 divided by 1.08. And we get negative 48.148. Repeating, but for our case, we know that's negative 48.148, and we want it to be a whole number, but as close to 1,000 as possible. So we know it's going to round to negative 48. That's closer than negative 49, because it's only 1.48 off. So our answer for this question is going to be negative 48. Alright, now let's move on to the next part, inequalities. Create, solve, or interpret linear inequalities in one variable. Inequalities are a bit harder to solve, but still very doable. So we'll cover a couple of those. Now solution. 3x minus 5 is greater than or equal to 4x minus 3. So, when we're dealing with an inequality, you can keep in mind the sign that's here, but for the most part, we treat it pretty much the same way that we do when there's an equal sign. So in order to solve this inequality, got to get the variable on one side first. So we're going to subtract 3x from both sides to make sure that the variable isn't there on the left. Negative 5 is greater than or equal to x minus 3. And now we're going to add 3 to both sides. Negative 2 is greater than or equal to x. Now, an important thing to note when you're dealing with inequalities is that while most operations are the exact same as when you're dealing with an equal sign, the only thing that changes is when you're multiplying or dividing by a negative. You want to remember to flip this inequality. If I were to multiply this by negative 1, 2, but to flip this sign is less than or equal to negative x. Same thing if I were to divide by negative 1, or negative 2, or negative 3, any negative number at all. You have to flip this inequality sign when you're multiplying or dividing. But for this one, we didn't need to do that. Alright, so now we have to identify which of these is not less than negative 2. Because the question asks for. Really important to make sure that you see this not sign and not just immediately choose negative 2. Negative 3 is less than negative 2, negative 5 is less than negative 2, negative 2 obviously is equal to negative 2. So we know that the answer is negative 1. It is greater than negative 2. Let's move on to another inequality. This one is a very weirdly phrased inequality, but is an inequality nonetheless. By the way, feel free to pause it if I'm going too quickly at any moment, or don't have enough time to read the problem, because I've already seen most of these. So I'm kind of skimming through them in my head. So between 12 and 18 ears of corn per hour. This is the amount of corn that you're shucking or husking. And you want to figure out what is a possible amount of time in hours that it could take. So it's important to realize this isn't a multiple choice question, right? And it's asking for a possible amount of time. That means there are multiple answers to this question. There are multiple answers that the computer will say, oh, yeah, that's good. So we only need to choose one of them. This is a very weird inequality problem because it is technically an inequality problem, but it really doesn't work like one. So you know that you have to do 72, and you know that you can do anywhere between 12 and 18 an hour. So all you have to do, choose one of them, or any number in the middle if you want to. You can choose any number from within here and plug that in as your value. You just want it to be a whole number, and it'll work perfectly fine. Because you're doing actual objects like this, you want the amount of hours, right, to be whole. You can't enter in a fraction or anything like that. So you choose one of the numbers, divide 72 by that amount, right, because you need to shuck 72 husks of corn. This is the rate at which you do it. You get 6. And that's your answer. Simple as that. You can do the same thing with 18 if you want it. 72 over 18 equals 4. Both of these answers work perfectly fine. All you have to do is choose one of them. Right. Just a quick tip. Just to keep it consistent and just to keep it fairly simple, I usually tend to choose the lowest number possible because for some reason it's just easier for me to deal with smaller numbers in my head. I can do this equation a bit faster in my head than I can do this. So whatever you're going to choose to do, just try and stick with it so you just have a defined method for everything. It's really nice to have in the back of your pocket. Alright, let's look at the next problem. Posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. Let me just write that. I just like to write the numbers that I figure will be important down. Delivery truck is carrying X identical boxes, each weighing 14 pounds, so it's going to be 14 times X, likely. Combined weight of the empty delivery truck, empty, keyword, and its driver is 1,400 pounds, or 4,500 pounds, sorry. What is the maximum possible value of X that will keep the combined weight truck, driver, and boxes below the bridge's posted weight limit? So the minimum possible amount you can have with 0 boxes is 4,500. And then you add 14 times however many boxes you have. So this is going to be our expression. 14x plus 4,500, right? And we're going to want to make that less than or equal to 6,000. Because it's asking for the maximum possible that will keep it below, I'm sorry, not even equal to, just less than. If it said below or at, that means it would be equal to as well, but because it says just below, it's just less than. So we solve this like we would any other equation. We get 14x is less than, subtract 4,500 from both sides, get 1,500. And now you divide both sides by 14. 1, 0, and 7. And you get 0.1027 point something, like 31, something like that. So because you want the most amount of whole boxes that's still less than this, your answer will just be 107. Can't have part of a box, so this is your answer. Alright, that's enough for inequalities. You guys should be able to get it. Now, this particular section is a bit odd, this particular topic. I could only really find one real question that covers this topic. There's some topics that will be tested a lot less than others. The first two that you saw will be tested a lot. This one, not so much, but it's still important to know it. Alright? This is more about understanding how the equation works and how to build one with two variables. So, first and foremost, we read, Armand sent M text messages each hour for 5 hours. Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone Saturday afternoon? So we're going to add the amount that Armand sent plus the amount that Tyrone sent. And we know that he sent M messages an hour for 5 hours, 5M. P messages an hour for 4 hours, 4P. So this is going to be the total amount of messages that they sent. 5M plus 4P. It's important not to get confused with the numbers in the variables. You want to make sure M matches up with 5, P matches up with 4. That's what they correspond to. So not too difficult of a topic. It's just that you want to understand how to structure an actual equation with two variables from words. That's all that you really need to know for this particular one. Alright, let's go back. Create and solve a system of linear inequalities with two variables. Alright, so let's do this first one. As you can see, page 445, it's going to be a long video. Pretty long video, considering we're 27 minutes in already. But it'll be a worthwhile one. At the very least, it'll take me a couple of days to make it. Alright, y is less than negative x plus a. Y is greater than x plus b. In the xy plane, if 0, 0 is a solution to the system with inequalities, which of the following relationships between a and b must be true? Okay. Negative x plus a is greater than x plus b. Okay, so when you see answer choices like this, right, you know that you're not really going to get an actual value for x. There's no numbers here other than 0, 0 that tell you anything really about how to get a and b, and 0, 0 isn't enough to do it. So you understand that you're going to have to look for a relationship among the system of inequalities. It's not a direct solve, it's looking for a relationship. So let's just see what plugging in 0, 0 will do for us. Alright, if you get 0, because it's the only information that we have to use. So we get, for this first one, 0 is less than, negative 0 is just 0, plus a, and we get 0 is greater than b, or 0 plus b, sorry. So these both equal, 0 is less than a, and this goes to 0 is greater than b. Well, if we see here that b is less than 0 and a is greater than 0, that of course means that a has to be greater than b, because a is positive, b is negative. So that's going to be a for us. So it's important to realize we don't have enough information to find the actual values of a and b. They don't really give us anything huge, and considering the answer choices, we don't need the actual values of a and b. All we need to do is use the information that we have and try to find some sort of relation between these two. Alright, now let's move on to the next problem. This one involves a coordinate plane. Alright. So for this one, in the system of inequalities, y is greater than or equal to 2x plus 1, and y is greater than 1/2 x minus 1. Which quadrant contains no solutions to the system? Okay, now let's just try and roughly graph what it would be, because it'll probably give us some insights. Now again, you don't have to make this graph too good. This is positive 1, this is negative 1. 1/2 x minus 1 has a slope of 1/2, and we know it passes through here, because of the y equals mx plus b we talked about earlier. Right? And then we know that the 2x passes through here, positive 1, and it's going a lot quicker at a rate of about 2 up here. So we notice immediately, right, that because it's a system of inequalities, right, it has to satisfy both of them. The area which is satisfied by this first line is above y is greater than all of this area. Oh, wait, I probably shouldn't have drawn it like that. So like, up to this line, above this line, and the area satisfied by this is more like this. Just like that. So the area where these two cross is the overlapping area. So you can realize pretty quickly that there's only one quadrant that this line right here doesn't touch, and that is the fourth quadrant. For this line, right, you have areas in it that satisfy it from all four quadrants, but for this line, this fourth quadrant doesn't satisfy it. And because we need it to be for both lines, right, because it doesn't satisfy for one, it doesn't satisfy for the system, which means that quadrant 4 is going to be the one that doesn't work. Right? This area here overlaps for quadrant 3, this area here overlaps for quadrant 1, and this area here overlaps for quadrant 2. Nothing for quadrant 4 though, because this is only for this 1/2 x minus 1 line. Alright. A bit messy, but hopefully you got the point. Alright. Now we're going to do creating a system of equations and solving it. Yeah. This is actually one of the more common things that you'll see on the SAT as well. A lot of these in the first section are really common. So, a food truck sells salads for $6.50 each and drinks for $2 each. Now we'll just call the amount of salad sold x, the amount of drinks sold y. So this will give us the total amount that you make. We know that the total number of salads and drinks sold in one day was 209, and the amount that they got was 836.50. So we'll make this equal to 836.50, and we'll do x plus y. Right, this is the total number of salads and drinks equals 209. This is actually a really common format that you'll see in the SAT. I've seen plenty of things like this, whether it's talking about adult and children tickets for movies, whether it's talking about food, as you see here, or like cookies and brownies at a bake sale. They'll give you two different prices for two different things, and they won't tell you how much of each one, but they'll tell you the total that you get by this equation, and they'll tell you how much they make, and they ask you for one of these values. They ask you, in this case, for the salads. So that's x right here. So we're going to be solving for x. Alright, so now that we have these, we can do a pretty simple transformation to this equation that'll make our lives a lot easier. So we keep this 650 x plus, we'll just simplify this to 2y because it's the same thing as 2.00. 836.5, and again, the 0 doesn't really mean anything if we just leave it as 0.5. So, and now we're going to multiply this by 2 so that when we subtract this equation from this one, the y's cancel out and all we have is the x's. It's important to know, if you have two variables, you need two equations to figure both of them out. If you have one variable, one equation. Three variables, three. So as soon as we have these two equations and we know we only have two variables, we can figure them out with ease. The way I'm doing it is probably the easiest way. I'll show you another way to do it afterwards. So you get 2x plus 2y. The reason I chose to cancel out the y is because it told me that I was looking for the salads, and I know that the salads is the x. So by doing it this way, I figure out the salads first. So I don't even have to figure out what the amount of drinks were. I can just get the salads immediately. So 418. And we get 4.5x equals 418.5, and this is on a calculator section, so 418.5 divided by, oh, that's not divided by, 4.5 is 93. So the amount of salads we got is 93. B. The other way that you could do it, this way is much slower so I wouldn't recommend it, is you use substitution. So you isolate the variable in one of them. Obviously this one's going to be easy to do. So get y equals 209 minus x, and now we plug this value in for this y. Again, didn't matter whether I chose x equals 209 minus y or y equals 209 minus x. It's just I want only the x's to be there so that I can figure out the salads first. So we do 6.50 x plus 209 minus x equals 836.5, and we get 6.5x plus 418 minus 2x equals 836.5. And after we do 4.5x Just combine these like terms, and we subtract 418 from both sides. We get the same answer as we did before. As you can see, these steps lead to the same exact thing. I just prefer this way because it feels a lot simpler than having to do 2 times 209, 2 times minus x, and so on. Alright, and that's how you solve that problem. Move on to the next one. Alright, this is a pretty standard one. No context, no nothing, just math. Something you'll see every once in a while. SAT doesn't do this often, but when they do, should be able to capitalize on it, save a bit of time. 3x plus 4y equals negative 23. 2y minus x equals negative 19. And now we're going to multiply the second part by 2. 3x. Again, we want to do the whole subtraction thing. We could go for substitution like we did in the last one, but I think subtraction is easier. So for this one, all you have to do to get rid of the y's is multiply this by 2. So I'm just going to choose to do that. You could choose to get rid of the x's, but I'd rather just get rid of the y's. Or y minus x equals minus 2x, right? Minus 38. Everything multiplies by 2. I did do that in the last problem, didn't I? Okay, yeah, I did. Just making sure. Always important to double check. If you ever are like in the situation that I'm in, you do a similar problem afterwards and you're not sure if you did in the last problem, you should probably check it just to make sure. Because that happens to me a lot. So we subtract this equation. So this is going to turn to minus, and then let's get rid of these parentheses. And this is going to turn to plus and plus. So 4y minus 4y, 3x plus 2x, 5x, 38 minus 23, 15, and x equals 3. Now immediately, again, a bit of a time save, we see that only one of these has an x value that's equal to 3. So you don't even have to calculate the y value. You can just choose b. But if you really want to make sure, you can plug this x back into one of these equations. I'll do this one because it looks simpler. Two y minus x equals negative 19. And we get 2y minus 3 equals negative 19. 2y equals negative 16. Add 3 to both sides. Y equals negative 8, which is the value that we have right here. So the answer is B. Check something. Alright. And we go. Alright. This next one I'm actually going to skip just because I feel like if you're able to solve this problem, it's the exact same thing. So we'll just move on to the next one. Okay, now actually let's just do it for the sake of it. Why not? Extra practice. Just make sure you're up to speed on everything. B equals 2.35 plus 0.25x. C equals 1.75 plus 0.40x. And so it's asking B and C are the price of beef and chicken. It's asking when are they equal. So if B and C are equal, these two equations are equal. So let's just do that. 5 plus 0.25x equals 1.75 plus 0.40x. Subtract 0.25x and 1.75x from both sides. You get 0.6. Again, 2.35 minus 1.75. And then we're subtracting 0.25x from both sides. So we get 0.15x. And now all we have to do is divide 0.6 by 0.15. We get 4. So x equals 4. And it's important to realize that is not what they're asking. They're asking either B or C, because we know they're equal, when x equals 4. So we plug it back into one of the equations. C equals 1.75 plus 0.40 times 4, 1.75 plus 1.6 equals 3.35. So your answer is going to be D. If I make any mistakes, by the way, feel free to correct me. I'll go back and try and change it in the video if I can. I do that occasionally, especially when you're doing this many problems. But on the actual test, if you have all these concepts down and you're focusing really well, you should be perfectly fine. Alright, this one, again, not too difficult. X plus 2y. Or we do it the other way. X plus y equals negative 9. X plus 2y equals negative 25. Again, looking for x, so I want to get rid of the y's. You can multiply the top equation by 2, so I can just subtract them. 2x plus 2y equals negative 18. And now we're going to subtract x minus 2y equals 25. I want to just change all the signs. And now we get x equals 25 minus 18, 7. Luckily, these two turned out to work out really well for us, so we get our answer of 7 pretty quickly. This is a Griden question, so all you would have to do is put in 7. Yeah. You can plug it back in, check for y if you really want to, but it's not necessary to do so. Alright, these questions are actually pretty easy. Interpret the variables and constants in expressions for linear functions within context presented. All that means is we're going to look at that y equals mx plus b formula, and we're just going to try and see what the m and the b actually mean. This is, again, the same format as y equals mx plus b. Just replace y with h and x with a, and it's the same thing. So it's asking based on, okay, so it's a model of the height of a boy in terms of age, a. And it's asking based on the model, what is the estimated increase in the height every year. So it's saying every year as the a increases by 1. Oh, I'm on the grab mode. As a goes up 1, right? How much does the h go up? Well, I mean, if you're more experienced with linear equations, you'll know immediately that it's just 3. But if you need to think about it a little, just try plugging in some values. When he's age 1, right, it's going to be 31.6. When he's age 2, it's going to be 6 plus 28, 34.6. When he's age 3, 37.6. It goes up 3 inches every year. That's all the slope means in this situation. So your answer is going to be 3. Yeah. I'm just explaining some math problems. Alright, so moving on to the next one. And we copy it over here. Kathy is a repair technician for a phone company. Each week she receives a batch of phones and needs fixed repairs. The number of phones she has left to fix at the end of the day can be estimated with the equation P equals 108 minus 23D. P is the number of phones left, and D is the number of days she has worked that week. What is the meaning of value 108 in this equation? Okay, so the number of phones she has left to fix goes down with each day. So if we just look at this equation a little bit and we understand what's going on here, she's a repair technician. Each week she receives a certain number of phones, right? That number of phones is somewhere in this equation. Each day she fixes 23, right? So the number of phones, hint hint, goes down by 23 every day, and P is the number she has left. So once we look at this equation, it's pretty simple to realize, all things considered, that 108 is the total number of phones that she has to repair beginning every week. We know this because the only number that goes down by 23 times the number of days, the only number that could be, is the number that she starts with each week. It's pretty apparent that she doesn't repair it at a rate of 108 per hour, because otherwise it would be multiplied by D, the number of days that she's done. 108 per day. It's not 108 per hour because we're dealing with days, not hours. And it's not going to be within 108 days because we know that it's her weekly quota. So we know that it's going to be, she starts each week with 108 phones to fix. Let's move on to the next one. Okay. And this one is a bit more interesting. It is a graph instead of an equation, but it has the same principles behind it. Whenever I see a graph, I just like to think of what it would be in equation form. The y-intercept is 5. We know this is obviously linear, it's just a straight line. Y equals mx plus b. So we know that the b is going to be 5 because that's the y-intercept. Just leave space for the slope. And then we know it goes from 5 to 8 in 1 hour, and then from 8 to 11 goes up 3 every hour. So that's the slope, 3x. And it's asking, what does the c-intercept, this 5, don't get confused when it says c-intercept, it's just referring to this axis they labeled at c, that's a c-intercept, when it intercepts that axis. What does the c-intercept represent in this graph? So what does the cost at 0 hours represent? The cost is the initial cost of renting the boat, right? We know that because obviously you're starting at 0 hours. So it can't really be the increase in cost because it's just the initial price. It's before you've actually spent any time in the boat, so it can't be increase, right? The total number of hours the boat is rented, that wouldn't make sense because you have this as an axis, right? So these numbers tell you how long the boat has been rented. The y-intercept is a point on the graph. So it shouldn't have any correlation in telling you how long the boat has been rented. That's what this axis is for, right? So you can cross out this and this. The total number of boats rented, this graph is the total cost of renting a boat by the hour. So it's not going to be multiple boats. So it has to be the initial cost of renting the boat. You know, most of the time when you have x equals 0, when it's the y-intercept, or I guess in this case c-intercept, it's pretty much always just going to be the initial cost, the initial height, the initial pressure, the initial something, whenever you're dealing with a problem like this. Alright, so that's enough for that section. And understanding connections between algebraic and graphical representations. Alright, this one is not too bad, and it only really comes in one type of form. Let me just zoom out a little bit on this so I can get the entire thing in. The title will be cut off a little bit, but it's the same graph, just a different problem. Which of the following is the relationship between h and c? We know that the intercept is 5, right? We're just figuring out in this equation what m and b are in this equation, in y equals mx plus b. So we know that the b is 5 because the y-intercept is 5. Pretty simple. And now we go from 5 to 8 in the first hour, 8 to 11, 11 to 14. It's pretty simple to subtract, and you realize that we're going up by 3 every hour. We do rise over run, 3 over 1. We get our slope is 3. Now we just have to plug in the right variables. Y in this case is c, and x in this case is h. You know that because, let me do that. You see, okay, well it's not on this graph because it got cut off, but there's a c above this y-axis and an h to the right of this y-axis, or to the x-axis. The c is what represents the y-axis, and the h is what represents the x-axis. So you just plug in h, and that's going to be your answer. Not too bad. You'll see a couple of these questions, not many though. It's a pretty rare topic. Alright, now we're going to move on to the next section. We're going to go on to problem solving and data analysis. This section is actually quite interesting because there's never any problem solving and data analysis questions on the no calculator portion. They're all on the calculator portion. All of these tables, all of these graphs that they're trying to get you to do, these things involving units and measurement, these things involving percentages, all on the calculator section. All of them. There's never any of them before. Alright, so let's go over them. Use ratios, rates, proportional relationships, and scale drawings to solve single and multi-step problems. This is the most common problem solving thing that you'll see. And it sounds pretty complicated, but it's not actually too bad. See if I can get this over. And then we'll zoom out a little and try and get the second part of it as well. Alright, so let's look first at this question. When you're looking at a table, to be honest, you don't need to look at the table first. Look at the question first, and then look at the table. because a lot of the times there'll be a lot of excess information that you really don't need. Unless it has a context above it, there's no need to look at the table. If it has context above it, any words up here, you want to read that first, and then read your questions, but just a table, you can just look at this. The following best approximates the average rate of change in the annual budget for agriculture and natural resources from 2008 to 2010. So we're looking at agriculture and natural resources, 2008 to 2010. Alright, so we're looking for rate of change. Rate of change is the same thing as slope, same formula. 488,106, right? And y2, let me just write down the formula for slope in case anyone doesn't know. It is y2 minus y1 over x2 minus x1. In this case, the y is the actual numbers in the table, and the x is the year. Minus 358, 708 over 2010 minus 2008. So you get, again, these will all be on the calculator section, so just do it. 488,106. Oh, wrong one. Minus 358,708. And it's going to be divided by 2010 minus 2008 is just 2. 64699. 6, 4, 6, 9, 9. And when we're looking back up here, you can see that it says in thousands of dollars. The table lists the budget in thousands of dollars. You can see it pretty easily when you look at these answer choices. None of them are even close. So either you grossly made a mistake, or there might be something like this where they simplify the numbers in the tables because it just is too big. So we know that because it's in thousands of dollars, it's 64,699,000. So we're going to add 3 zeros. We're just multiplying this by 1,000. That's all we're doing. And we choose the closest one, which in this case is 65 million, because it says which of the following best approximates. Oh, that's not the right button. And no, oh, okay, there we go. Which of the following is, which program's ratio of its 2007 budget to its 2010 budget is closest to the human resources program's ratio of its 2007 budget to its 2010 budget? So let's look up the human resources. Yeah, human resources ratios 2007, 2010. 051, 050, or 050, 5921, 379. So we have a calculator. Let's just figure out what that exact proportion is. Or 051, 050 divided by 5921, 379. And we get 0.68414. 0.68414. Alright, now we look at these and we can approximate which one looks like a pretty similar increase. If you look at this number, 0.68 is around 0.66, which is 2/3. It's the closest fraction I can think of. Which one looks like it has approximately a 2/3 increase? This one's only 100k. It looks like 1/3 increase. Again, a 1/3 increase. Barely any increase. Again, doesn't really look like a 2/3 increase. This one looks pretty substantial though. This one right here. So let's see exactly how much it is. 263, 463. Divided by 464, 23. Say 233, yeah. Alright, 0.567. That is not too close. For me at least, I'd be satisfied with this answer. Just because, just looking at these, I can tell that none of these are going to be a bigger increase than that. However, if you want, you can look at every single one. You can just divide the 2007 number by the 2010, and you'll get the proportions for every single one. I'm not going to do that because, to be 100% honest, it's kind of a waste of time. Once you get this first ratio and you find a fraction that's pretty similar, all you have to do is like, oh, what's 2/3 of this? This is like, let's just say, I don't know, 70k. It's like 260k, right? So, I'm sorry, 2/3 would be like, let's say 140k. So we add that to this. That's like what, 400k? It's decently close. What's 2/3 of this? Let's see, 1.4. Around 2/3 would be what, maybe like 0.8. So we add that to this, it would be like 2.2 mil. 500k is a pretty big difference. These are just so close together, like you can see immediately, not even close to 2/3. 2 million to 3 million, that's about 1/3, so 0.33. 370 to 480, it's like about 100k increase, so less than 1/3. So you can see pretty clearly that it's going to be the public safety. However, you can check every one if you have time for it. I don't recommend checking every one just because usually there'll be a pretty obvious answer. In this case, it was public safety, and it honestly just takes a lot of time to do. But if you have time, if you really want to make sure, checking every one is the right way to go. Alright. Alright, so this first topic that we're covering comes in a lot of different ways. This one, again, is just a ratio. When y is 24 and x is 6, when y is 24 and x is 6, y equals kx when y is 24 and x is 6. So k equals 4. Right? Now it's asking, so we know that y equals 4x. Y is always going to be 4 times x. So if we get x equals 5, we just know y is going to be 20. 4 times 5. Pretty simple. A lot easier than the last one. And still technically falls under the same section. Alright. This one is pretty similar to the problem we did 2 times ago, but a lot easier. It is asking, according to the line graph, the number of portable media players sold in 2008 is what fraction of the number sold in 2011. So it's just asking the number sold in 2008, which in this case is 100, right? 100 million, divided by, let's just write that out, the number in 2011, which is 160 million. Now, just remember, whenever you're doing fractions, you can cancel stuff out pretty easily if they have zeros at the end. Divide top and bottom by 10, that cancels out this 0. So we can just keep canceling out zeros until one of them no longer has a 0 in that position. Okay, we can't cancel out this one because 0 and 6 don't cancel out, so we get 10 over 16. From here we can divide both by 2. You have 5 over 8. And that's the answer you would put in for your grid-in question. Alright, let's go to the next one. Solve a single or multi-step problem involving percentages. Okay. Copy this one. And we are going to paste over here. A laptop at a computer store, or a laptop computer at a store that gave a 20%, make sure that's 20% discount off its original price. The total amount you paid was $P, right? Including a 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Alright, so let's say T is the original price, right? 80% discount, that means that it's going to be, or 20% discount means it's going to be 80% of the original price. So that's going to be 0.8T. That is the new discounted price. Now, in order to get P, right, we're going to have to multiply this by 1.8. So that's, again, this one part is to get all of 0.8T plus an additional 8% sales tax. So we multiply, or actually in this case, yeah, we multiply 0.8 and 1.08 together, or actually, don't actually have to, they keep them separate here. So we get 0.8 times 1.08 T equals P. It's important to realize now we're looking for T, not P. So we have to divide by 0.8 and 1.88. T equals P over 0.8 times 1.08. So it's D, this one. Let's go to the next one. Alright, Katerina is a botanist studying the production of pears by two types of pear trees. She notices that type A produces 20 more than type B. Based on her observations, if type A trees produce 144, how many did type B produce? So it's 20% more. That means that we're going to get whatever value this is and multiply it by, pretty simple, 1.2. Remember, you're always going to have calculators for this portion, so you don't have to worry too much about it. $172.8. So let's go back here. Oh, I'm sorry. I wrote it the wrong way. Type A trees produce 20% more than type B. I was thinking it was the other way around. So if 144 is the total amount, right? That means however many type B produce, right? Let's just call it B for now. This is the amount that type B produce. You multiply by 1.2 to get 144. So let's divide both sides by 1.2. B equals divided by 1.2. 120. That is the amount we're looking for, and that is the answer choice B. Let's move on to the next problem. Alright, so now that we moved on from percents, it's a pretty simple topic. All you really have to understand with percent is, 100% is equal to 1. 8% more means 108%. 20% off means 80%. And all these are equal to is dividing by 100, 1.08, equal to 0.8, equal to 1. Once you keep all of these in mind, you'll be able to solve most of these problems pretty easily. Again, if you have any questions at all, feel free to ask me. Just making it so I don't have to explain the same thing to everyone over and over. Can help you on the sections that you really need help with. Alright. Hospitals store one type of medicine in a 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? Alright. So, this one, again, just conversion. You have 2 decagrams, right? Which is equaled, according to this equation, right? 1 decagram is 10 grams, so 2 equals 20 grams. Now you take those grams, plug them into the next unit, and you get 20 grams equals 20,000 milligrams. Pretty simple. You multiply this 20 grams by the 1,000 milligrams, and that's your answer D. More simple problem. And now we look at this one, a unit conversion problem that deals with time instead. Alright, so you have 30-minute local television station sells time slots for programs in 30-minute intervals. 30 minutes. Station operates 24 hours a day, every day of the week. What is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? So it's 2 days. How many hours is that? That is 48 hours. 24 per each day. And then each of those 48 hours has 60 minutes in each. So we're going to do 48 times 60. And we're going to divide them into 30-minute intervals. So this answer is going to be divided by 30. Instead of multiplying this out, I'm just going to simplify a little bit. If we just divide these first, then you get 2. You can do this because multiplication and division doesn't matter what order you do them in, you'll get the same answer. Multiply this in, and you will get 96. Second, gotta get my battery. Be right back. Give me 1 second. Okay. So now we're going to look at a topic that I've only actually ever seen once. So it's a very rare topic, but it is kind of an interesting one. So it is, given a scatterplot, use linear, quadratic, or exponential models to describe how variables are related. Again, I could only find one scatterplot when I was looking for this, which happens to be this one. But it is pretty simple. And I'll even make a problem, just because I think once you get the hang of it, it should be pretty easy. For this particular problem, it's simply asking which of the following graphs best shows a strong negative slope. Association, alright, keep this in your mind, association equals slope. That means the same thing. So in this case, you're looking at a linear model, or you're looking for a linear model. Which of these most strongly shows a negative slope when you do the line of best fit. This one is going to be something like, I mean, that's approximate. It could also go like this. It really could be anything. It's pretty hard to judge here. This one, it's pretty simple. It's going to go like this, positive. This one's positive. This one, however, is a pretty strong negative slope. So we're going to choose D. Again, when it says strong, that means more negative. That's all that it's asking for. So that's why D is going to be our answer. And let's say I had a scatter plot that looked like, or I was asking which shows exponential growth. This is the key word for exponential functions. Exponential growth means that it's going away from zero, so graphs that look like this, right? Or graphs that look like this, going away from zero. Exponential decay is the exact opposite, it's going towards zero. So graphs that look like this, or this. Alright, so let me just draw scatter plots. Which of the following is the best example of exponential growth? And I might draw something like this. Just pretend these are all like reasonable dots. And then maybe something like this. And then maybe something like this. Alright, so I think it's pretty easy to see here. This one's linear, this one's a decay function, and this one's growth. That's all you're going to get at these types of problems. As long as you know the key terms growth and decay, and then you know what a positive and negative association are. Just positive slope, negative slope. Strong just means how negative the slope is. If it's like -5, which is really steep, -5, this is stronger than a -3, right? A strong positive association, a 3 is, this is weaker than a 5. It's just how steep it is. The steeper, the stronger, for association. And then for exponential functions, it is just growth and decay. Alright. Those are two key terms you want to keep in mind. Or should I say sets of terms? Okay. Use the relationship between two variables to investigate key features of the graph. Alright. These problems are not too bad at all. So, put this up here. All we have to look at is, John runs at different speeds than part of the training. Graph shows target heart rate. On which interval is the heart rate strictly increasing, then strictly decreasing? Let's see, between 0 and 30, and it increases, but then it just stays the same, so it's not strictly decreasing afterwards. 40 and 60, it goes up then down, increasing then decreasing. That's perfect. It's 40 to 60. That's our answer. Let's just look at the other ones to make sure though. 50 to 60, it decreases first. That's wrong already because it says increasing then decreasing. Decreases then increases, and then 70 to 90 stays kind of the same, then all of a sudden spikes, and then stays the same again, never decreases. So we know it's going to be 40 to 60. So not too bad. Again, it's just looking at a graph and trying to figure out what it's saying. Marilyn's hike. The graph shows Marilyn's distance from her campsite during a 3-hour hike. She stopped for lunch 30 minutes during her hike to have lunch. Based on the graph, which of the following is closest to the time she finished lunch and continued her hike? Well, I mean, it appears that she's moving away from the campsite during all of this. All of a sudden, it stops for exactly 30 minutes. So it's pretty easy to see that this part right here, where she's not moving, is when she's stopping and having lunch. So at the end of this part, right here, it's going to be, I'd say, around 140, right? It's obviously not 110, that's when she starts it. It's closer to 1. It's not 2, it's not all the way over here. It's not 1240, 1240 is way back here. So yeah, it is 140. So that is our answer, C. All that it is understanding what the graph is asking for and being able to deliver. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? It's good to know f of x is the same thing as y. X is just x. F of x equals y. So at what point does it have the minimum y? This one right here, the lowest value on the entire graph. What x is that? That x is -1, -2, -3. That's our answer. Simple as that. So these questions aren't that bad. It's just looking at a graph, maybe sometimes looking at the context, seeing what it's trying to ask for, and then interpreting it. It's not too bad at all. After a couple problems, you should be able to get the hang of it. And now we have this problem. And the number of rooftops and solar panel installations in 5 cities, shown in the graph above. In each city, rooftop solar panels installation in 5 cities. The total number of installations is 27,500. What is an appropriate label? The vertical axis of the graph. So it's saying that if you add all of these, it's going to be 27,500. Let's just add these numbers to see what we get. 9 plus 5 plus 6 plus 4 plus, we'll say 3.5. These all add up to, this adds up to 27.5. So how do we get from 27.5 to 27,500? Let's check by dividing. 27,500 divided by 27.5 equals 100. Again, you would have your calculator if you really have trouble solving this, but it should be pretty simple to see. If you move this decimal places back 3, you get 100. So it's 27.5. Wait, I'm sorry, I mean 1,000. My bad. Yeah, moving it 3 back is the same thing as multiplying by 1,000. So the number of installations is in thousands. Alright, compare linear growth with exponential growth. This problem was quite weird. This topic was quite weird. It was incredibly difficult for me to find, and even the one that I found doesn't really feel like that good of a problem. Oops. Alright. Paste. Scroll a bit to the right. Alright, so 2 samples of water of equal mass are heated to 60 degrees, and then they're left to cool. One is poured in an insulated container, one is not. This one appears to be pretty linear. This one appears to be pretty exponential. Then they're left for 70 minutes to cool in a room that has a room temperature of 25. That's why it solidifies off at 25. The graph above shows the temperature of each sample at 10-minute intervals. Which of the following statements correctly compares the average rates at which the temperature changes of the 2 samples? So in every 10-minute interval, magnitude of rate of change, it's asking which statement is correct, so we have to read the statements to see which one is right. In every 10-minute interval, the magnitude of the rate of change temperature of the insulated sample is greater than that of the non-insulated sample. Well, I mean, if you just look at it, the insulated sample is changing less, right? That means the magnitude of change is lower. The magnitude is just the extent to which it changes. So because of that, we know that this is false. However, B is saying the exact opposite, that the non-insulated container is changing more rapidly with greater magnitude than the insulated sample, so we know that B is correct. Again, it's just looking at a graph. This one is just a particular graph and interpreting what it means. A skill that you should get pretty familiar with. It's not too bad at all. Alright, using a two-way table to summarize categorical data and relative frequency and calculate conditional probability. This is something that people might struggle with just because it's something that we don't do too much in school, but it's actually not too bad at all. After doing a couple problems, you should be able to do it perfectly fine. So let's look at it. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. Survey data was broken down as shown in the table above, which the following categories accounts for approximately 19% of all these survey respondents. Okay, so we know how many survey respondents there are. It's asking which of the categories accounts for approximately 19% of all of them. Let's figure out what 19% of this is first so we can see which one it looks like. So, again, all of these questions that in this section are going to be only on the calculator part, so you don't have to worry about that. Let's look at this, 310 times 0.19 equals 58.9, so approximately 59 people. If we go back to our thing, which one has about 59 people? Oh, this one has exactly 59 people. Men taking geometry. So that's the one that we're going to choose. It is not too bad at all. Conditional probability. All the conditional probability means is essentially conditional probability is like if I had all of these 310 students and I were to randomly choose one student, what's the probability that they would be a male taking geometry? 19%. All we did here is work backwards around it, but conditional probability just means that you're looking for a certain condition within a big group, and the probability of finding that certain condition is what we're looking for in most cases. Just like this one. Here we go. Alright. Down in the table above, were produced by a sleep researcher. We're studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes. Group Y who observed later bedtimes. If a person is chosen at random from those he recalled at least one dream, what is the probability that the person belonged to group Y? So by saying at least one dream, you're making sure that we do not count this section who does none. It's 1 to 4 or 5 to more. So we look for within these two people, right? How many belong to group Y, right? So in this one we have 28 plus 57 belong to group X, and 11 plus 68 belong to group Y. So 28 plus 57 here is 85. 11 plus 68 is 79. So we're going to get how many people belong in group Y? 79 out of the total. Let's see how much you get when you add up both of them. 164. 79 over 164. So out of the total 164 people, 79 were from group Y. Right? 164 people that experienced one or more dreams. 79 were from group Y. 85 were from group X. The probability of choosing a person from group Y randomly is 79 over 164, which is answer C. Alright. Now we'll move on to our next topic. Use statistics to investigate measures of center of data, analyze shape, center, and spread. These questions are going to be about mean, median, and mode. Pretty simple. There's one additional thing that's pretty important to focus on. And range. And it's called standard deviation. I'll explain that as well, but unfortunately I could not find a problem that exhibited it. Alright, so based on the histogram, which of the following... Oh, did I cut off some part? Oh, it's just... based on the histogram above of the following... Oh yeah, I cut off a pretty big portion. It's fine, I'll just read off here. Based on the histogram above of the following, which is closest to the average arithmetic mean of the number of seeds per apple? So we look here, we just have to add all of them together. So 2 had 3 seeds, there's 2 3s. Let's just write it down on a list because I like doing this first. Then there's 1, 2, 3, 4 5s. 1 6, 2 7s, and 3 9s. So once you get all of these, you add them all up. You get 20, 14, 7, 6, and 6. 3, you get 73. So you have a total of 73, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 apples. Divide 73 by 12, and you will get, let's just check, approximately 6 apples. Approximately 6. So you get C equals 6 because it's asking which is the closest. So the next problem. This is a problem I see pretty often. is table above lists the lengths to the nearest fish of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data. So the mean, right, will change a little bit, right? The median, right, which right now is just this 12 right here, will go from being this 12, right, this middle number, to the average of these two 12s, which is still going to be 12. So the median is going to remain the same. So it's going to change to the least. The range, right, it will go from 8 to 28, or 24 minus 8, which is 16, to 24, or, sorry, not 24, 16 minus 8, which is 8. So it'll change by 8. That's a pretty big difference. And if you're trying to save time, you can kind of just tell that the mean won't change by a whole 8 points. It's just too many numbers for 24 to change it by a whole 8 points. But if you want to do it precisely, you would just add all these together. 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 11 plus 11 plus 12, 12, 12, 12 12 plus 12 plus 12 plus 12 13, 13, 13, 14, 14 13 plus 13 13 plus 14 plus 14 and 15, 15, 16 15 plus 15 plus 15 plus 16, and we get 253. And now we know that it's originally 21, but because we're taking out the 24th one, or this last value, it's only going to be 20. So we're going to divide this by 20, and we get 12.65 as opposed to the 253 plus 24 divided by 21, the average of the original values, which is 13. So it's not changing by a whole 8, it's only changing by 3-ish. So the value that changes the most is the range. Now, evaluate reports to make inferences, justify conclusions, and determine appropriateness of data collection methods. I actually like this one the most because it's honestly probably the easiest. Wrong one. Let's look at this. Alright, a researcher conducted a survey to determine whether people in a certain large town prefer watching sports on television to attending a sporting event. Asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences of all people in town? Alright, so sample size, right? It's 117 people. That's a pretty large amount. I don't think that that's necessarily going to make it the least likely to be reliable. Population size. We have no clue what the population size is, so obviously this isn't going to change anything. The number of people who refuse to respond. This truly is never the answer. The number of people who refuse to respond doesn't really affect the results of the survey. Where the survey was given. Now, this survey was given at a local restaurant. That means that people are already going to be more prone to go outside, right? And it's going to be people who are just happier maybe watching an event with their friends on TV in the local bar as opposed to watching it at home by themselves. So, where the survey was given actually makes a pretty big impact on the opinions of the people there. For that reason, where the survey was given is going to be your answer. And to be 100% honest, it's almost always your answer for these types of problems. Where it was given, the conditions it was given in. Alright, let's go on to the next one. A square field measures 10 by... Let me just put it over here first. A square field measures 10 by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is a square and has side lengths of 1 meter. No two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. Results are shown in the table below. Region A, 107, 147, 146, 135, 149, 141, 150, 154, 176, 166. So the following is a reasonable approximation of the number of earthworms to a depth beneath the grounds of the entire field. So you're trying to make an assumption based off of the data that you're given. So what we're going to do is we're going to add all of these numbers together. Let me just do this really quick. Oh wait, my bad, you guys can't see that. I'll just leave it here. 107, 147, 146, 135, 149, 141, 150, 154, 176, 166, 1,471. Which one is that closest to? 1,500. So that's going to be our answer. So pretty simple problem again. It's just take your information and you use it for whatever problem is asking you to do for this thing, for this type of problem, and for this one, you're trying to see what makes the survey not too reliable. And hint, hint, it's almost always going to be where the survey was given. Yep. Alright. Now we're moving on to the next section. Passport to Advanced Mathematics. These problems are going to be more mathematical based instead of like analyzing graphs and data. And it's going to be not really algebra, but different other mathematical methods that you need. So the first one, create a quadratic or exponential function. The only one I could find for this one was an exponential function, but the quadratics I will just give an example for. An example that you'll see pretty often in the actual test. So, a radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions models the remaining amount of substance in grams t years later? So it's important to know how to format a exponential function. And I'll give you a general formula that you can use for every one of these questions on the SAT test. Let's say f of t equals a, let me zoom out a little bit so you can see both parts. A times x to the t. This t will almost always remain constant, right? This a is going to be whatever your initial value is, right? In this case, it's 325 grams. And then this x is going to be however much it changes by. Decays at an annual rate 13%. Decays, that means it's going down. That means it's going to be 0.87, right? 1 minus 0.13 is 0.87 to the power of t. And that's going to be our answer. Can use a similar formula for every single exponential function that you come across. This t will only ever change if it's asking something like, if t is years, how much would it change? But it changes by 0.87 every month. As long as it's an annual rate and it's years, or a monthly rate and it's months, as long as the rate and the unit of time are the same, then it's perfectly fine. And that's going to happen 99% of the times on SAT tests, but it's something to watch out for. You want to make sure that the rate is the same as the time. If this were a monthly rate, right, I would have to do t times 12, because instead of having t years, I would have to have t times 12 months, right? If it was 1 year, then it would be 12 months, 2 years, 24 months, so on. And now let me just give a quick example of a quadratic function. So let's say a rocket launches at a height of 5 feet with a velocity of 16 meters per second, right? Write an equation to satisfy to model the launch. And when they give you these quadratic equations, they actually give you the formula for it. It is something like negative 9.8 t squared plus 16 t plus 5. Oh, sorry. They won't give you this, sorry, my bad. They will give you negative 9.8 t squared plus vt plus h. Yeah. Okay, give me a sec. So you plug in the velocity for the velocity that they give you, and the height for the height that they give you. And that is quite literally it. Very easy question. All it's asking you to do is plug stuff in. The same way, the exponential function is pretty much the same thing. It's just that for the exponential function, you have to remember the form. For the actual quadratic function, it'll give it to you. So you don't have to worry about that as much. Let's move on to the next one. What? Okay. So, this next topic is determining the most suitable form of an expression. Let's go here, here. It's essentially asking us to find. This is the main form that you'll find it in, but it's going to ask us to find the best form. It's almost always going to be a quadratic equation in which to identify a certain thing. So, to the following equation is an equivalent form of the equation from the graph above, from which the coordinates of the vertex A can be identified as constants in the equation. So, for those of you who don't know, there's 3 forms for quadratic equations. There's general form, just like this one right here, ax squared plus bx plus c. There is factored form, right, where you have a times x minus the first root and the second root. And then lastly, there's vertex form, where you have a and then x minus h squared plus k, right? This first form, general form, tells you where the y-intercept is, right? The c. The second form, factored form, tells you where the solutions are, the two roots, the two zeros. And this last form tells you where the vertex, which is h comma k, is at. So you want it to be in this last form. Only one of these is actually in that form, and that is d. X minus 1 squared minus 16. So you immediately know that that's the correct answer. But if there is more than one in that form, you're going to want to find which one actually is equivalent to this general form. So you do x squared minus 2x plus 15. And for now, oh yeah, we'll just let it equal to y. And now we want to do something we call completing the square. In order to complete the square, right, we want to get this x squared and the singular x into the form x squared, right, minus, sorry, let me fix this really quick. Wrote that wrong. We want it to be in the form a squared minus 2ab plus b squared. Of course, the a is going to be the x, right? So you're going to get x squared minus 2x times b plus b squared, right? Or you can get it as x squared plus 2xb plus b squared. The way to figure out your b, you do whatever this value is, right? In this case, it's negative 2. This b value over 2. Oh, sorry. You take this negative 2 and you plug it into the equation negative b over 2a. So you do negative 2 over 2, and a in this case is just 1. So you get 2 over 2 equals 1. So your b is going to be 1. It's going to be x squared plus 2x plus 1. Because 1 times 2x is 1. B squared 1. So you get x squared minus 2x plus 1 plus 15 equals y plus 1. We add 1 to both sides. Now we're going to do x minus 1 squared. We can factor this into x minus b squared, right? Plus 15. This should be a review over completing the square. If anyone has more questions on completing the square, just talk to me and I can go more in depth on it. But yeah, for now I'm skimming through a lot of things pretty quickly. Just because I feel like most of you should know how to complete the square by this point, and this should just be a reminder of what you're doing. Those of you who don't, just ask me. I'll be happy to help. Squared plus sorry, now we have to subtract 1 from both sides. 14 equals y. And Oh, it looks like I'm really dumb. It says minus 15, not plus 15. Oops-y. So, doesn't change too much. Let's change all these pluses to minuses. Minus, minus, minus. And now when we subtract, it'll be negative, minus 16, which is the answer that we have here. So that's how you complete the square normally and figure out what vertex form is. Let's move on to the next problem. Alright, create equivalent expressions involving irrational exponents. So, in this problem, it's similar to figuring out quadratics, except you're going to be dealing with two variables, and we're not trying to solve any equations here. We're just going to try and simplify them into equations that are essentially the same. So, when you're dealing with expressions like this, right, what you have to realize is that when all of these exponents are even, you can simplify really easily, right? Because instead of viewing them as a to the power 4 and a squared, let's pretend there's another number, right, called x. X equals a squared. And we'll say y equals b squared, right? If we plug these two into this equation, right, get 9x squared, right, a squared to the power of 2. Just do 2 times 2, that's 4. Plus 12xy plus 4b squared. And all of a sudden, this becomes a lot, or not b squared, sorry, 4y squared. All of a sudden, this becomes a lot easier to factor, right? So you look at this, you say, oh, what can get me 9x squared? First of all, you're going to have x's here. It's either going to be 1 and 9 or 3 and 3. But the only numbers I see here have squareds next to them, so let's go with 3 and 3, just because I think that will probably lead to better results. And we know that this is going to be plus, right? If we multiply 2y by 3x here, right, we get 6x. And if we do that again, we get 12x. And then on top of that, 2y times 2y, it's 4y squared. So we get 3x plus 2y squared. Now we plug our a squared and b squareds back in. We get 3a squared plus 3b squared. And we square these. So it's important to realize that you can, whenever your exponents are even, you can just simplify them down by dividing everything by 2 using this little substitution method. And all of a sudden, this equation becomes pretty simple. Again, if you need any help with this factoring, feel free to ask me. Alright, creating an equivalent form of an algebraic expression. This is where we get out of factoring and get into a lot easier territory. To be 100% honest, factoring is one of the hardest things you're going to have to do on the test. So again, if any of you have questions, ask. But these ones should be pretty simple. A over B equals 2. What is the value of 4B over A? Again, when people look at questions like these, they're like, oh, I gotta find A, I gotta find B. But in a lot of cases, you don't really need to. You can just transform one of them into the other. So, first and foremost, we see that these equations are incredibly similar. There must be some way for us to transform them into the other. So first thing we're going to do is take the reciprocal of both sides. We get b over a, right? We switch the numerator and denominator, equals, if this was 2 over 1, which is the same thing as 2, right? It would now be 1 over 2. And now we just need to multiply this top value by 4. Multiply this top value by 4. and we get 4 over 2, which equals 2. And that is our answer. So not too bad, just transforming one equation into another. This one, again, number 5, is solving a quadratic equation. So let's do a couple of examples. Now again, when they say solving quadratic equation, they're going to ask it in a variety of ways. Solving quadratic equation itself is pretty standard. They're not going to give you anything too complicated, but they're going to ask it in a couple of different ways. Like for this one, you don't actually need to figure out the roots of the function. You need to figure out what the function actually is. You know that when g is 4, or when x is 4, g of x is 8. So we'll plug that in, equals a times 4 squared plus 24. 8 equals a times 16 plus 24. So we're going to subtract 24 from both sides now. Negative 16 equals a times 16. Divide 16 on both sides. A equals negative 1. Right? So now we have this. We can complete our equation. G of x equals negative x squared. Same thing as negative 1x squared plus 24. And now we're going to substitute negative 4 in. So we get negative 4 squared plus 24, right, equals g of negative 4, which is negative 16 plus 24, and that equals 8. Alright, so pretty standard stuff. They're going to ask, again, solving quadratic equations, not just a standard thing that we normally do, but also a variety of different ways to go around it. For this problem, what is one possible solution to the equation above? Let's try and just figure out what the equation actually is. So whenever we're solving, we want one of the sides to equal 0. So let's get into that format. X to the power of 5. I'm just going to distribute this equation really quick. Minus 5x to the power of 3 equals negative 4x. We're going to add 4x to both sides. Plus 4x equals 0. Now we're going to factor an x out because we can. We always want to factor a common term if possible. Whether that's x, whether it's a constant. If you can get it out, if it's common in every single term, then just get it out. It makes it easier, no matter what. Plus 4 equals 0. And now it's important to realize this is a grid-in question. And it's asking me what is one possible solution. If it didn't have this x is greater than 0, I would immediately just put my answer as 0 and then get on with my day. Because there's no reason to go further past this point if they don't have this one restriction that prevents you from putting 0. But since they do have it, we're going to have to solve it. Again, all of my exponents for x are even. That means I can create a new variable and make that into x squared and make this entire thing a whole lot simpler. Minus 5y plus 4, and all of a sudden it becomes a pretty basic factoring problem. So let's do this. Y minus 5 and y plus 1. This might take you a little bit to think of, but as you can see, I'm sorry, I'm done. Y minus 4 and y minus 1. As you can see, negative 4 times negative 1 equals 4. Negative 4y minus y and y squared. So yeah, when you FOIL it all out, it comes into this equation, and you're going to get now we substitute it back in, x squared minus 4 and x squared minus 1 equals 0. And we're going to have to factor these again. If you don't know, this simple formula, a squared minus b squared equals a plus b times a minus b. Very basic formula that you're going to want to remember. Helps so much when you're factoring. X squared obviously is x squared. 4 is 2 squared. So you can do x plus 2, x minus 2. And then for this one, x squared, and 1 is just 1 squared. So you do x minus 1 times x plus 1 equals 0. So you can do negative 2 here, you can do 2, you can do 1, you can do negative 1. Any of these answers will work, and you can grid in any of these answers. Actually, technically, you can't grid in negative answers on the thing because there's no minus sign. And it said if x is greater than 0. So you have 2 or 1 as your options. So it boils down to just getting it down to a simple quadratic formula that you can solve. You always want to make sure that one of the sides is 0. That should be your first step whenever you're solving quadratics. And this one, again, pretty simple quadratic. The whole a squared plus b squared thing really comes in handy. 1 second. I don't think I copied it. There we go. And we get t squared minus 4 equals 0. So we get t plus 2, and then t minus 2 equals 0. And so the values of t are negative 2 and 2. Just an easy, simple quadratic, but of course, since it says t is greater than 0, we're going to have to count this out as extraneous, and it's just going to be positive 2. Make sure when you're solving quadratics that you see every inequality here, because they do this a lot, and if you're not careful about it, you're going to fall for it and choose a negative answer. Alright. Now, this one actually should be in a different section, so I'm going to go skip that for now. We'll do this instead. Here we go. Alright, yeah. Alright, so the height equals negative 4.9 t squared plus 25t. Alright, so the equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upwards from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? So it is asking, when will the height be 0? That is all it's asking. T squared plus 25t. Now, first things first, we factor out a t. Again, whenever you can factor out a number, always do it. Always makes it simpler. Every single time. Right? So this tells me that the first 0 is just going to be at 0. So 0, 0 is a point. That makes sense. When the rocket first launches, it obviously starts on the ground and then goes, or sorry, when the ball first bounces, it starts on the ground and then goes up. Right? That's not the value we're looking for. We're looking for when it first hits the ground after it starts going up. So what we're looking for this value right here. Negative 4.9 t plus 25 equals 0. Negative 4.9t equals negative 25. T equals 25 over 4.9. We get 5.1. So our answer will be approximately 5 seconds. Now again, any questions of factoring, feel free to ask. Most of you should have this down, and it should just be review, figuring out how to solve different problems if they ask it to you in different ways. Alright, now we're moving on to the next section, add, subtract, and multiply polynomial expressions. This one is a pretty simple, this one's pretty simple. All you need to know is an example of the problem that I'm giving you right now, and then you also need to know FOIL. Okay, let's just write this down. X squared y minus 3y squared plus 5xy. And then I'm going to distribute this negative to everything. Plus x squared y minus 3xy squared. And then plus, just want to make sure this is a 3, not 5, plus 3y squared. Now we're going to add, if we see any like terms, x squared y, so we're going to get 2x squared y, 3y minus 3y squared plus 3y squared, those are going to cancel out. 5xy minus 3xy squared. So those won't cancel out. Oh, I'm sorry. It says 5xy squared. Well, it does cancel out actually. Or not cancel out, but it turns into plus 2xy squared, which is this answer right here. So all that you really need to know is, for this general thing, adding and subtracting polynomials, all you need to know is that you can add like terms, which means that it's the same exponents of the same power. The coefficients don't matter too much, they're the numbers you're actually adding and subtracting, but in order for them to be like terms and to be added together, same exponents, same powers. Like this is x squared y, you cannot add that to xy squared, because the x has a different exponent, the y has a different exponent. You can do it to x squared y again. 5xy squared, you can do that with negative 3xy squared. Exponents and exponent powers have to both be the same in order for you to add and subtract them. And the second thing we need to know for this section, couldn't find a problem for it, but it's pretty simple, FOIL, and how it expands to bigger problems. Let's say you have 3x plus 2 times 5x plus 1. FOIL. Take this first number, multiply it by this. Then you go to this second number. Alright, so you get 15x squared, and then you get 3x. Now you're finished with the first number, you go to the second number, do this, and then do this. Plus 2. Most of you know FOIL. It works for when you have equations specifically like this. But when you have equations of bigger values, some people often get stuck when you have something like 3x squared plus 2x plus 5 times 2x plus 1. What do I do here? Here's what you do. You take the smaller expression, right? In this case, it's 2x plus 1. You take the smaller one because it's easier. You rearrange that to be first. Again, this is just ease of mind. You don't actually need to do this, but I prefer doing this because it's easier to see. And now you take this first number, multiply by the first. Then you do the first number to the second, then to the third. Then you take the second number, do the same thing, multiply by the first, then the second, then the third. Doesn't matter how many terms, you just do this process over and over. Doesn't matter how many terms, doesn't matter how big it is, it'll work. So you get 6x cubed plus 4x squared plus 10x plus 3x squared plus 2x plus 5. Now you combine like terms, you get 6x cubed plus 4x squared plus 3x squared, 7x squared plus 10x plus 2x plus 12x, and then plus 5. And that's how you do it. Alright, now we've covered that section, we can move on to the next one. Solve an equation of one variable that contains radicals or contains the variable in the denominator of a fraction. This one is kind of hard, I cannot lie. But once you get the hang of it, you should be able to do it with these. This first problem. Again, this is all about knowing how reciprocals work. So, you have 1 over x plus 2 plus 1 over x plus 3. This is the same thing as 1. Sometimes when I have like big numbers like this, I like to write them in the actual way. This is the same thing as 1 divided by. Remember, 1 over, the fraction, is the same thing as 1 divided by this value right here. 1 over x plus 2 plus 1 over x plus 3. Now let's combine these two fractions first, because that'll make it easiest. Right? So in order to get this, the least common denominator between the two is going to be x plus 2 times x plus 3. So let's write that. That's going to be our denominator. To get this into this denominator, we have to multiply top and bottom by x plus 3. It's going to be x plus 3 on top, since it's just x plus 3 times 1. And then for this one, you need to multiply top and bottom by x plus 2. So you get 1 times x plus 2. Right, so we get x plus 3 plus x plus 2, so you get 2x plus 5 over x plus 2 times x plus 3. And here's where the 1 divided by part works. If you know anything about division, right, you should know that when you do this, it's the same thing as 1 times the reciprocal of this. So x plus 2 times x plus 3 over 2x plus 5. And all of a sudden, you have a pretty simple equation now. X plus 2 times x plus 3 over 2x plus 5. And now we just have to multiply this part out. And we get x squared plus 2x plus 3x, 5x plus 6 over 2x plus 5. And that is answer choice B. So the important thing to remember here is when you have 1 over some really big value, change it into this division sign really quick. That way you can focus on this first, try combining them, and then once you get a pretty solid answer that you can't simplify anymore, then you can just flip it over, and that's your answer. That's what you do whenever you have the variables in the denominator. Oops. I guess it's okay. Let's do this problem. Alright, and for this problem, it's asking for, let's make sure yeah, okay, I did that right. For what value of x is the function h above undefined? So let's just think about this for a second. How can we get this function to be undefined? If you know what undefined looks like, there's a couple of different ways to do it, but when you see a fraction, the first thing you should be thinking of is when the denominator is 0. This is almost always going to be the answer whenever you see undefined. Technically, if you have a negative inside of a square root, that would work as well. But actually, that wouldn't necessarily work because the SAT recognizes imaginary numbers. So this is pretty much the only way, to be honest, when you have the denominator as a 0. So you're looking for how you can make this denominator 0. X minus 5 squared plus 4 times x minus 5 plus 4 equals 0. And now we will simplify everything. X squared minus 10x plus 25 plus 4x minus 20 plus 4 equals 0. So we get x squared minus 6x plus 5, or sorry, not plus 5, plus 9 equals 0. And now we can factor this into x minus 3 squared equals 0, and we get x equals 3. At x equals 3, h is undefined because the denominator equals 0. Again, if you need any help with factoring, just talk to me. And now we'll deal with the radical. Alright, so we have square root of 2k squared plus 17 minus, and we know x is 7, so let's just plug that in, equals 0. So what we want to do whenever we have a radical in our equation, we want it to be alone in the equation, on one side of the equation. What else is on this side of the equation? The negative 7, so let's add that to both sides. This way, we can just square both sides of the equation, and all of a sudden this radical is no longer a problem. So whenever we have an exponent inside of a radical, get it by itself on one side of the equation, and then square the equation. Get the radical by itself and square it. It's 49. Now we're going to subtract 17 from both sides, and we get 32 divided by 2, k squared equals 16, and we get k equals 4. Perfect. And now let's move on to the next topic, because the radicals, pretty simple. All you have to do, isolate the radical, get it on one side of the equation, everything else is on the other, and square both sides. Now we're going to do an incredibly specific topic. There's really only one type of this, so let's just do the problem. Really simple. y equals 3, y equals ax squared plus b. In the system of equations above, a and b are constants, for which the following value does the system have exactly two real solutions. Okay, so obviously y's are equal, so 3 equals ax squared plus b. And now let's just make this into general form so that it is easier for us. Plus b minus 3. We're a pretty simple format here now. So let's see. Have exactly two real solutions. How do we figure out the number of real solutions? The easiest way to figure that out is to use the discriminant. Those of you who don't know, the discriminant is b squared minus 4ac. This is the number that's inside of that square root in the quadratic equation. And if this number is positive, that means there's two real solutions. If it's 0, that means there's one real solution. And if it's negative, that means there's two imaginary solutions. So let's just try plugging some things in, right? A obviously is still a here. C now is b minus 3. And because there's no plus x value here, there's nothing here, that means the number next to it has to be 0, so that it gets cancelled out. So we're going to get 0 minus 4a, and then b minus 3. 0 minus 4ab minus 12a. Again, just want to reiterate, the normal form is ax squared plus bx plus c. And so because we don't have this entire thing, that means that this b value is 0, which cancels this entire part out. The c value is going to be b minus 3. Just want to make that clear. And so now we have negative 4ab minus 12a. And so now we need to start looking at answer choices to see which of these makes this choice positive, right? So let's see. If a is negative 2, right? Let's plug that in. That would be 8b and plus 24. And b is 2. That would be 16 plus 24. That would be positive. That works, right? That's exactly two real solutions. Now let's try some other ones just to make sure. For b, that would be 8. That would again be 8b plus 24. Appear to have done something wrong then. Oh, I'm sorry. I didn't distribute this negative to the 3. This is supposed to be plus 12a plus. So it would be 8b minus 24. I apologize. So a would actually not be the correct answer. You get 16 minus 24, which is negative 8. For b, you get, let's write this down. You get 16 minus 24, which equals negative 8. For b, again, you get this 16, or sorry, you get 8b minus 24, which now the b is 4, so you get 32 minus 24 equals 8. Positive, that works. If you put in 2, you get negative 8b plus 24, and if b is 4, that means it's negative 32 plus 24, which makes it negative 8. And if a is 4, that makes it negative 16b plus 48. And if b is that, then it's negative 48 plus 48, which is 0, which means it's exactly one solution, not two. So the only correct answer is b. So here it's just important to realize they're looking for the discriminant. Yeah, that's about it. Whenever it's asking for the number of solutions and you have quadratic, you're going to want to use the discriminant, b squared minus 4ac. That's just a rule that you want to keep in mind in general. Just a certain formula that you want to keep in mind. Alright, let's move on to the next one. Okay. I believe the section title for this one got deleted, but it was supposed to be solve a linear and exponential function instead of linear and quadratic. Let's scroll a bit to the right. Paste this. And so the key here is to realize, well, I mean, there's nothing really you can do directly, right? Again, if you have one equation, two variables, you cannot solve that for both of them. So you have to look at this answer choice and see if there's any manipulation you can do. Well, let's see. You can change the bases to both be 2. That's always a good idea, changing the bases. Right? 8 is 2 cubed, which then is to the power of x. This is equal to 2 to the power of 3x. Again, when you have a power to another power, you can just multiply those powers together. So you get 2 to the 3x over 2 to the y. Oh, that's not where the y should go. And again, another rule of exponents that you want to keep in mind. When you're dividing exponents, that's the same thing as subtracting them. These are equivalent equations. You want to remember this. It's almost like moving down a level of operations. Multiplication moves down to addition. Division moves down to subtraction. That's how I like to think about it. Doing the exponents moves down to multiplication. I think of it as different levels. You know, like square roots and exponents, right? This is a tier, the top tier. Then you have the middle tier, which is multiplying and division. Let me write that the other way around. Division. And then you have the bottom tier, which is subtraction and addition. So when you're doing it to the entire, when you're moving the operation from the whole equation with the bases up into the exponents, you simply move down a tier, right? If you're dividing, you move down to subtraction, right? If you're square rooting, you move down to division, right? If you have the square root of x, that's the same thing as x to the power of 1 over 2, right? Because it's just x to the power of 1 here, and the square root of that. You're moving from square roots down to division. That's how I like to think about it, and I think it's a pretty good way to keep that in mind. So if you ever need a quick and simple way to remember what you're supposed to do with exponents, just remember this little chart right here. When you go from operations with the bases and you want to move them to the exponents, you have to move down a level. You cannot do anything with the bottommost tier because there's nowhere lower to go. So if you have 2 to the power of 3x minus 2 to the power of y, you can't go and simplify this into one base with the exponents. You cannot do anything with that. Okay. And now that we have that, now you can see that these two equations, or these two expressions, are exactly the same. The SAT does this intentionally. There's no other way to solve this expression. So, now you can do 2 to the power of 12, and that's your answer, right here. Alright, let's move on to the next one. Again, a pretty similar one. And I want to remember your rules for exponents, and you'll be able to do this one too. So you have x to the power of a squared, right? Right, squared. You want to bring that inside, moving down a level from exponents to multiplication. X to the power of 2a over x, again, x to the power of b squared. That's going to be x to the power of 2b. We go down from exponents to multiplying, and then equals x to the 16. So we get x to the 2a, again, you're going from division to subtraction, moving down a level, minus 2b equals x to the 16. So you get 2a minus 2b equals 16. You get a minus b equals 8. So this entire thing actually wasn't even necessary, because all you're looking for is a minus b, and that's your answer, 8 right there. Simple as that. So whenever you have a pretty complicated equation with exponents, like these two, it's usually going to come down to you remembering your rules for exponents and simplifying them into a linear equation. Just pretty straightforward, addition and subtraction. Alright, rewrite simple rational expressions. Okay, so for this one, let's copy this, paste it here, place image, and if a equals 5 rad 2 and 2a equals rad 2x, what is the value of x? Okay, so pretty simple. We want to make these two equations somehow interloop. So how can we do that? Let's just, I'm sorry, because we want to make these two equations interloop. I just want to make sure this is clear. Because we have two variables, and without two equations, we cannot solve for two variables. How to make these interloop? Obviously, just plug the value of a in here. 2, 5 rad 2 equals rad 2x. And now, when we're dealing with something with radicals, we want to isolate it and then square both sides of the equation. Luckily for us, it's already isolated, so all we need to do is square both sides of the equation. And we get 2x equals 10 squared is 100, rad 2 squared is 2, multiply those together, you get 200, and you get x equals 100. Just like that. Pretty simple. This, again, is really similar to the radical one we did earlier. Not too much of a difference. Should be able to solve it. Same principles we used for that one. Understanding the relationship between the zeros of factors of polynomials. Zeros and factors of polynomials, sorry. Okay. So, first problem. This is an important concept to learn, and kind of an interesting one to understand, right? So, when you're dealing with polynomials, right? If you were to have a polynomial, say, the p of x equals some weird things of things, like x to the power 5, x to the power 4, whatever, right? When you plug in a value, right? In this case, you plugged in 3, you get out, I don't want to confuse people. So when we do p of 3, we get -2. And what's important to realize is that when we do p of x, right, this entire equation here, divided by x minus 3, we're going to get some weird polynomial. And then, right, we're going to get like something, whatever, and we're going to get a remainder of 2. This will always be true so long as, or sorry, a remainder of -2. This will always be true whenever this happens, and it's a polynomial. In fact, by polynomial, I just mean any function that's in the shape of like, oh, x minus 3, maybe it's like x cubed minus 2x squared minus plus 1, right? Anything like that, this is true. So when you do p of a certain x value and you get the y value, right? If you divide by x minus this x value, you get that as your remainder. This means, right, that if you have 0, your remainder is going to be 0, which means that it's a perfect factor. It's the same principle behind having your normal factors here, right, that you would do with your quadratic, right? Just backwards, right? When you factor this out, you get x minus 1 times x minus 1, right? You know that if you plug in 1 for x, that you get 0. If you were to know already, right, that if you plug in 1 to this equation, you're going to get 0, because you just luckily guessed it somehow, right? Then you would automatically know that x minus 1 is a factor for this. And all you need to do is find out the other factor. It's the same principle here. So because p of 3 is negative 2, when you divide p of x by x minus 3, the remainder is going to be negative 2. If the remainder was 0, then x minus 3 would be a factor of p of x. It's an important concept. Again, if you have any questions, I know it might be pretty confusing. But if you can get this down, this certain topic, which maybe comes up once throughout the entirety of the test, will be a breeze. Very simple to understand once you get it down. All you need is to think about it a little bit, and once it makes sense in your head, it'll be easy for you to understand and to do. Alright, so let's move on to the next topic. Or sorry, not even the next topic, the next part of this section. The next part that we need to go over is graphing based on zeros. So, if we have a function, I'm going to place that image. If we have a function, and we know that it has 5 distinct zeros, that means that it's going to touch the x-axis exactly 5 times, right? Touches it 1, 0, 2, 3, 4. That's not 5, it's not the right one. 1, 2, 3, 4. Again, not 5, not the right one. 1, 2, 3, 4, 5, 6. This time it's 6, so it's 1 over. 1, 2, 3, 4. See, this is barely touching, and then 5. So that means D is your answer. This one, pretty simple. If a function has exactly 5 zeros, that means it's going to intercept the x-axis exactly 5 times. If you understand that, then this should be pretty easy for you. Use structure to isolate or identify a quantity of interest. Okay, so this is just transforming an equation to figure out the quantity that you actually want. Oh, there we go. Let's copy this over. Alright, so we have A equals 1052 plus 1.08t, and we want to figure it out in terms of the speed of the sound wave, so in terms of t, right here. So what we're going to do, we want to isolate the variable, we're going to subtract 1052 from both sides. And now we're going to divide by 1.08. This is honestly a pretty simple thing. If you know how to solve equations at all, if you're familiar with like just solving for y, solving for x, then you should be able to do this. Something that you should get down pretty easily. Simple algebra. But yeah, so the answer here is going to be A. All you have to do is make sure that you're looking for the right variable. This one gives an example of one that looks a bit harder, but really isn't that much harder. Let's move this over. Control V, and we're going to place the image. Again, a lot of math looks scary, but it's really not that bad. The formula above gives the monthly payment M needed to pay off a loan P dollars at or % annual interest over n months. which of the following gives p in terms of m, r, and n? So they already give you the equation. Now instead of looking for m like they did there, you're going to want p. So what do? Well, you have this huge fraction in front of it, right? I'm not even going to write it down because I don't want to rewrite all of that. It's a lot of work. Well, why don't we just divide by that fraction? Dividing by a fraction is the exact same thing as multiplying by its reciprocal. So if we do that to both sides, then we'll be able to just solve it. Easy as that. So we go here. Let me just erase this really quick. And we're going to multiply by the reciprocal on both sides. So we're going to get p equals, we're going to get this side on the top. Again, I'm not going to write it just because there's no real reason for me to. It's a pretty simple problem. And this side on the bottom. And we'll look for which one has that. Right, so we want this to be on the bottom, which is here, and this to be on the top, which is also here. So our answer choice is B. Simple as that. All we had to do was realize, well, we're looking for p, and there's a huge fraction right in front of it. So just multiply by the reciprocal on both sides, and that's it. We don't have to do any more math. No simplifying, no nothing. It's just a scary problem designed to look scary, but it's really not that bad at the end of the day. And that is it for our main 3 sections. These 3 sections will cover 90% of the test. So I recommend, if there's something that you didn't understand, something that you're still a bit iffy on, you understood that problem, but maybe if it comes up in a different way, you might not understand it, you want to try and focus on those type of problems. Ask me if you really need any help. But again, I must reiterate, this is 90% of the test, what we just covered. The next will be the 10% that comes as extra questions. Still important to know, but not as important as the other stuff. Alright, so these are the additional topics. This covers geometry, some basic trigonometry, and that's pretty much it, yeah. Alright, so solve problems using volume formulas. This should be volume and area formulas. I don't know why they named it volume formulas, but that's the official standard that they gave. So let's just try the first one. Let's copy this over here. Oh, I didn't copy it. There we go. And let's see. The figure above shows a regular hexagon with sides length A and a square with sides of length A. If the area of the hexagon is 384 square root of 3 square inches, what is the area in square inches of the square? Alright, so it's important to note that in the beginning of all of the SAT tests, right? Let me just pull up one for instance. They have a sheet that tells you formulas for areas and volumes. Just because the SAT wants you to focus not on memorizing stuff, but on knowing how to apply stuff. So let's look at it really quick. See if we can find the formula for the area of the hexagon. Alright, right here. Interesting. So it doesn't actually give you the formula for the area of a hexagon, but it does give you the formula for the area of a triangle. And that's important because when you think about it, a hexagon, right, is nothing but 6 triangles. And that's exactly how 6 equilateral triangles. It's exactly how we figure out the area of a hexagon. We realize that it's 6 equilateral triangles. This is always how you're going to figure out the area of a hexagon. It's just the easiest way to do such. Because this side is A, right, and these are all equilateral, again, 360 degrees, so each of these 6 is 60. And all of these triangles are equilateral, A, A. The formula for an equilateral triangle, this is one that you probably want to memorize. It's just going to help you. You could do it manually, but it's just a lot of work trying to do the Pythagorean theorem to figure out the height and then do it. Instead, it's a lot simpler to just know the formula. Area equals square root of 3 a squared, where a is the side. This is the side. By the way, the small a is the side. Over 4. So the area in this case, right, for the entire hexagon is going to be 6 times square root of 3 a squared over 4, because there are 6 triangles. So we just add up all of these areas, you get 6 times square root of 3a squared over 4. And that's going to be equal to 384 square root of 3 inches, right? So first thing we're going to do, we're going to divide this by 6, right? And we get 6, 4 square root of 3 equals square root of 3a squared over 4. Now we multiply by 4. On both sides, we get 256 square root of 3 equals square root of 3a squared. Divide by the square root of 3. 256 equals a squared. So we get a equals 16 as our side length, right? And now we have to find the area of the square, which just has side lengths a. So the area of the square is just going to be a squared. Didn't actually even need to find what a was, because already over here we figured out that a squared is 256, which is going to be our answer. So it's important to note here, whenever you're dealing with the hexagon, it's just 6 equilateral triangles. You can use this formula for the area of a regular hexagon. Area equals 6 times square root of 3a squared over 4. This is one of the few formulas you actually need to know, because it's one that the SAT expects you to figure out if you don't. Alright. Now let's look at this problem. This one is a lot more simple of a problem. Let's look at the practice section. It gives you the formula for the volume of cylinder. Volume equals pi r squared h, right? So let's write that down really quick. Alright, so it tells us the height is 8, and it tells us that the volume of the silo is 72 pi. So it's asking what the diameter is. Diameter is just going to be the radius times 2, so we have to figure out what the radius is. 72 pi equals pi r squared times 8. So let's divide by pi. 72 equals r squared times 8. And now let's divide by 8. So we get 6. We get 9 equals r squared, which gives us r equals 3. And it's asking for the diameter, which will be 2 times the radius, so we get 6 as our answer. Not too bad, especially because they give us the formulas. And this one is kind of like the final boss of them. Just a culmination of different shapes, all of which they give you the formula for. So, although it's a bit of work, it's not too bad. So let's try and figure out the formula of the center first, the center cylinder first. Already know, we looked at the last problem, the volume of a cylinder equals pi r squared h. We can see that the radius is 5 and the height is 10, so we'll get the volume of the cylinder right here is going to be 25, right? 5 squared is 25 times 10. Volume is going to be 250 pi. Now we have to get the volume of these two cones and add it to the actual cylinder to get the total volume of the entire thing. So let's see where the cylinder is. Here we are. 1/3 pi r squared times height. So pretty similar to the volume of the cylinder. The volume of the cone is just 1/3 pi r squared h. And we're going to multiply this by 2 because both of these cones are the exact same. It's just one is on top, one is on bottom. Same radius, same height, so it's going to have the same area. So we'll multiply by 2 really quick so we don't have to add them both together afterwards. And then pi, the radius again is 5 squared, and the height this time is only 5. So we get volume equals 2/3. And then 25 times 5 is 125 pi. So we get 250 pi over 3. Volume equals 250 pi over 3. And again, in order to get the volume of the entire thing, we have to add this to the volume of the two cones, volume of the cylinder plus 2 cones. And so let's do that on our calculator. $785, and then wrong one. Plus 785 divided by 3, 1046.6. So it will be 1047.2 because I didn't use the exact amounts for pi because there's none on this calculator. But if I were to, it would be this precise answer. When it's rounded, of course. It would be D right here. Use the trigonometric ratios and the Pythagorean theorem. Alright, so you guys should be familiar with the Pythagorean theorem. A squared plus b squared equals c squared. You can use that whenever you have a right triangle. And trigonometric ratios is one thing that not all of you might be familiar with. Okay. Let's move it over here. In triangle ABC, right? Let's draw a triangle really quick. It's always nice to have a picture. If you really don't need it, you don't have to draw one, but I personally really like to have pictures whenever I'm doing math, especially when I'm dealing with triangles. But if it's a pretty simple problem and you really don't see a need for it, then you don't need to draw it. Alright, so it is saying all of the side lengths are 1/3 of that in DEF. Okay, so in order to figure out what sine of f is, right, we need to know first how to figure out the sine of an angle. For those of you who might not be familiar with what sine, cosine, and tangent are, they are 3 functions in trigonometry. Essentially, they tell you the ratios of the sides based on the angles, right? So we have a pretty common acronym called SOHCAHTOA. For some reason, it's actually pretty easy to remember. No idea why, right? The sine, right? We split this into 3 parts, right? This S stands for sine. The sine of an angle, right? The sine of f. So let's just say f for now. We'll just pretend f is the angle we're looking for, which it is equal to the opposite side over the hypotenuse. O stands for opposite, H stands for hypotenuse. Cosine of f equals the adjacent side over the hypotenuse. And lastly, tangent of f is equal to the opposite over the adjacent. These are three things that you need to know for this test, right? So, the one that we're looking for, right? Say SOHCAHTOA in your head. Oh, we're looking for sine. That's the first one. Sine of f is equal to the opposite side over the hypotenuse. The hypotenuse, again, for those of you who don't know, is the side opposite the right angle. The biggest side in the triangle is called the hypotenuse, right? And in right triangles, it's always the opposite to the right angle. So we take this f, right? We look for the side that's opposite. Oh, it's this side. Okay. What's the length of this side? Let's just say, for instance, this isn't the actual problem. I'm just explaining SOHCAHTOA right now. It's 3. Let's say this is a 3, 4, 5 triangle. SOHCAHTOA, right? The sine of f is 3 over 5. The cosine of f is 4 over 5. The tangent of f is 3 over 4. This is the opposite side. This is the adjacent side. Adjacent just means right next to. And this is the hypotenuse. If we're looking for d, then these opposite and adjacent sides switch. Right? Now, if we're looking for d, right? Now this is the opposite side, and this is the adjacent side. So when they ask us for the sine of f, right? They're asking us for this opposite side, dE, over dF. Alright, so now let's go back to the problem. Now that we know what sine, cosine, and tangent are, and how to figure them out. Take this f, right? And we're looking for the opposite side over the hypotenuse, right? In order to figure that out, though, we have to realize, wait, if all the side lengths are divided by 3, right? Wouldn't the ratio still be the same, right? Like, let's say you had 3 and 6 as the sides, right? Sine of f of this big triangle would be 3 over 6. Isn't that the same thing as sine of the small one being 1 over 2, right? Because you just divide the top and bottom by 3. You simplify to 1 over 2. See, it's the exact same thing. Because you're dealing with a ratio, and you're dividing all the side lengths by the same number, the sine is going to be the exact same thing. Alright? So all we need to figure out now is the sine of c. Alright, so how do we get this AB side? That's where the Pythagorean theorem comes in. A squared plus B squared equals C squared. Right? AB, whatever that is, A squared plus B squared. 16 squared is 256. And lastly, C squared. 20 squared is 400. Now we're going to do A squared. What the? Am I on the wrong side? No, I am. Okay, A squared equals 2. Or sorry, A squared equals 144. Now A equals 12. So we get A equals 12 over here. And now we see that opposite over hypotenuse is going to equal 12 over 20. So sine of f is going to equal, let's see, 6 over 10, which equals 3 over 5. Alright, and that is going to be our answer. So again, keep in mind SOHCAHTOA, keep in mind the Pythagorean theorem, and then again, when you're dealing with ratios, if you change both these side lengths and trim them down by 3, it's not going to change anything. But it's important to realize, even if you don't realize this whole fact, you still will get the exact same answer. You get 16 over 3 here, you get 20 over 3, and you get 4. And you're still going to get the exact same answer when you do sine of f. So it's not a must to realize, right? But it is just helpful. So if you do see that fact, great for you. You just saved probably 20, 30 seconds. But if you don't, it's not the end of the world by any means. All you have to know is SOHCAHTOA, the Pythagorean theorem, to solve this problem. And of course, you need to know how similar triangles work. But it tells you every corresponding side has a length of 1/3. So I guess you don't even need to know how similar triangles work. It tells you that. So yeah, important things to take away. SOHCAHTOA, Pythagorean theorem. Need to know them for the test. Okay, adding, subtracting, multiplying, dividing complex numbers. If you do not know what a complex number is, you're going to struggle on the test. There will be at least 2-3 questions about complex numbers. Alright, so for a complex number, there's one thing you need to know. I is equal to the square root of -1. Normally when you're dealing with the square root of negative numbers, you just say, oh, well that's impossible. You can't have the square root of a negative number. But mathematicians decided to be a bit crazy. And they were like, well, let's just make it I. And now it is I. So when you're adding things like this, you treat it like you would any exponent, right? You just combine like terms. 7 plus -8, you get -15. 3i plus 9i equals 12i. Just like any normal exponent. So you're going to get 15 plus, or sorry, what am I doing? 7 minus 8 is not 15. Silly goose me. You get -1 plus 12i. Give me your answer for A. Now, when you're multiplying these two, let's say you were multiplying these two, right? Let me check if I have another problem for it. I have dividing. But for now, let's just say we're multiplying. 7 plus 3i times -8 plus 9i. You do FOIL like you normally would in this situation if I were a variable. So we do -56 minus 24i plus 63i. Oh, forgot to write the I there. Plus 27i squared. Now we just keep on the -56. 63 minus 24 is going to be 39i. And then what we have to realize is I squared is the square root of -1 squared. So I squared is going to be equal to -1. So instead of it being plus 27i squared, it's going to be minus 27. And now this equals, combine like terms again, -83 plus 39i, and that is your answer. That's what would happen if you were to multiply these. You FOIL, and whenever you see an I squared, you change it from I squared to -1 and multiply. Alright, converting between degrees and radians, and using radians to determine arc lengths. Also, using trigonometric functions to use trigonometric functions of radian measure. Okay, so for this, you need to know one major thing. You need to know what radians are. Radians are a way to measure angles. Just like degrees are, just like there are 360 degrees in a circle. Everybody knows that, right? There is 2 pi radians in a circle. It is the exact same thing. It's just, instead of measuring the numbers, we measure in 2 pi. Because that makes it a lot easier for us to deal with things like circles. So the conversion between the two, right, is 180 degrees equals pi. So if you have a degree value, let's say it's 60, and you want to convert it to radians, you multiply by pi over 180. If you have a radian value, let's say it's pi over 3, and you want to convert it to degrees, you multiply by 180 over pi. These are the conversion methods. It's important to remember radians are nothing but a way to measure stuff, just like degrees are. They're just an alternate form of degrees. That's all it is. Alright, yeah, so 60, right? 180, you get 1 over 3, you get pi over 3. You want to convert it back, you go this, that, simplifies to 60, right? These pi's cancel, and you just get 60 degrees. It's important to note, radians don't have this degree symbol like degrees have. It's just, you just don't write anything afterwards. That's it. So let's get to our first problem, so we can see more what it's like. Again, remember this converting between degrees and radians, because this might actually come up as a problem on the test. You need to remember the conversion factors. Pi over 180. If it's degrees, degrees are on the bottom. If it's radians, radians are on the bottom. Right? These two conversion factors are what you multiply by to convert. You need to remember these in case these are on the test. They might show up. And let's look at our problem now. Alright, so it says O is the center of the circle. The measure of angle AOB is pi over A radians. What is the value of A? Alright, so this is kind of a combination problem. I think it's a pretty good one. You can see that the coordinates of this is rad 3, 1. That means it's x. So rad 3. I'm just drawing this triangle in here, by the way, just to try and figure out what this angle is in degrees, so that we can convert it into radians. And this side is going to be 1, right? So in order to figure out what this angle is, we're going to use that sine thing we were talking about earlier. Well, we know that, well, if we look at SOHCAHTOA, right, as I was saying, the real reason we have these is so that we can use an angle to figure out side measures, or we can use the sides to figure out angle measures. So we have the opposite and the adjacent sides. Which one can we use? TOA. So tangent of AOB, right, this angle right here, is equal to 1 over the square root of 3. Now we can use the inverse of tangent, of 1 over the square root of 3, and we will get an angle measure that's easy for us to find. Let's look up Google calculator. because this one doesn't. No. Oh, okay. Let's do a trigonometry calculator. Oh, well, I don't want that. Oh, sorry, scientific calculator should work. Alright, so we'll use the inverse tangent of 1 divided by, and then we'll put the square root of 3, and that is 30. So it's 30 degrees. Again, if you have any questions about this, I know most of you will probably know about SOHCAHTOA, most of you will probably know about basic trigonometry, but feel free to ask. I will definitely just give you a quick crash course on trigonometry, and we should be good to go after, because it's not too difficult. You should be able to do it. We'll do pi over 180 to convert from degrees to radians. Remember, if you're converting from degrees to radians, degrees are on bottom. And we get pi, and we just simplify this really quick, over 6. So a equals 6. Quick way to figure it out. And the last thing that we need to do is figuring out arc lengths from angles. So this one I couldn't find a problem on, but I know that they exist, so let's just do an example one. If we have an angle here, let's just say it's theta, or sorry, not theta, my bad. Let's say it is pi over 3 radians. And we have a side length here, let's say it's 5, that's the radius, right, of the entire circle, but we only have the sector that's pi over 3. And we want to figure out what this arc length is. There's a very, very simple formula, and it'll show you why radians are so effective and why people like to use them in circles more than degrees. The formula to figure this x out is x equals, right, r times theta, where r is the radius and theta is the angle. So all you have to do is plug in 5 and pi over 3. And your arc length is 5 pi over 3. You might get a question like this on the SAT, because they specifically mentioned that they could test something like this, and they had before. If so, all you need to know is if it's in radians, you can use a simple formula to get this arc length. It has to be in radians though. If it's in degrees, convert it to radians, and then do this. Remember, to convert from degrees to radians, you just have to multiply by pi over 180. Alright, let's look at the next one. Apply theorems about circles to find arc lengths, angle measures, chord lengths, and areas of sectors. Okay, let's check what these are all about. Okay, and we paste this. Alright, so there are a couple of theorems that you're going to want to know for circles, and I'll just introduce you to most of them right here. In case you don't know, you can always just reference back to this. First and foremost, you have your perpendicular bisector thing. If you have a diameter and it passes through a chord, like this, any diameter, and it passes through the chord, and it's perpendicular, right? That means it bisected this chord. This chord is now split into 2 equal pieces. Alright, that's one pretty standard one that you might not see in your test. I don't think it's used often on SATs. So I don't think you need to worry about that one too much. But this one you probably do need to worry about. This one, if you have two tangent lines that meet up at a point, right? You can split it down the middle. And because they're tangent to a circle, by the way, any line that's tangent to a circle only hits it at one point, is perpendicular like this. Um, Alright, so because you have these two tangent lines, these two side lengths are going to be equal. Just like these two side lengths are equal, and just like this one in the middle is equal. Right? And that's pretty much all that you need for most SAT problems. So let's take a look at this one. Well, we see pretty obviously that's tangents, so we're going to do this. Actually, let me reconsider what other things you might need to look up. Let me look some stuff up. What other circles on SAT math formulas reviewing practice? Should be good. Okay. Circle formulas. Circumference. Area. Arcs. Okay. Okay. So I have another one. That might be useful. So when you have a circle, if two lines intercept the same arc, right? Because they're both intercepting this arc, and they're both on the edge of the circle, right? These two angles have the same measure. That's an important one that you probably need to know. And then I think with that, oh, another one is when you have your diameter and you have an angle that intercepts it, this has to be a right angle. Always. Every single time it is a right angle. Every time. If it intercepts a diameter, it is a right angle. With that, you should be pretty much good to go. Figure above point O. Alright, let's just draw this. Line segments LM and LMN are tangent to circles. For the circumference of the circle, what is the length of minor arc LN? Okay, so these are both right angles. You can split this into two equal triangles because you know these two. Side lengths are the same. The side length is the same. This is the same. They're congruent. So these have to both be equal. 30 degrees, 30 degrees. Which means that this is 60 and this is 60 degrees. Now we know that this entire thing combined is 120 degrees. And because it's 120 degrees out of the total 360 degrees in the circle, right? We know that this sector right here is 1/3 of the circle, which means this arc is 1/3 of the circumference. What we can also do, right, is do what we were looking at earlier, which I think personally is easier. Just wanted to show you this method as well, is we can convert this to radians times pi over 180. And then simply multiply by the radius. Or actually, oops. Cut again. I'll just fix this entire section. Fix up to 350. Yeah, okay. So because it is 120 degrees, if we divide that by the 360 degrees there is in the total circle, we'll see that this section is 1/3 of the total circle. That means this arc will have 1/3 of the total circumference of the entire circle. So you multiply 96 by 1/3, we get 96 over 3. And that is our answer. Oh, and that simplifies, that simplifies to 32. So a bit of a more complicated problem. Again, you're not going to see too many of these on the SAT, but it is important just to know these 4 major things. Again, if you see anything else on the SAT that you don't know about circles, just feel free to ask me. But you do not need to know too much about circles, just some basic things. Alright, let's move on to the next part. Of course. So, in a circle with center O, the angle AOB has a radian measure of 5 pi over 4. The area of the sector formed by AOB is what fraction of the area of the circle? Okay, so the area of the sector to the area of the circle is going to be the same thing as the area or the degree measure of AOB to the total amount of degrees in the circle. So since we're dealing with radians, and pi radians equals 180 degrees, there's going to be 2 pi radians in the entire circle. And so we're going to have 5 pi over 4 over the entire 2 pi in the circle. Let's bring this down. We get 5 pi over 8 pi, and we get 5 over 8. So the fraction of this thing to the entire circle is going to be 5 over 8. Just like that. Just like with the circumference, the area of AOB in comparison to the entire circle is the same thing as the degree measure of AOB in comparison to the entire circle. Use concepts and theorems about congruent and similarity to solve problems about lines, angles, and triangles. Okay. this is a couple of problems, pretty easy ones, and we're actually almost at the end. After this, there's 2 more topics, and then we'll be done with our session. We see 2 triangles already. We know that vertical angles, right? These 2 should be congruent. We don't know anything about vertical angles. Basically, if you have 2 straight lines, when they intersect, these angles will be congruent, and these 2 angles will be congruent. So the ones opposite each other will always be congruent when two lines intersect, when 2 straight lines intersect. So, struggling a bit. These 2 will be congruent because they're on opposite sides. And let's read. Once find the length x across a lake. Okay. The lengths are represented by AB, EB, BD, and CD. In the sketch, we're determined to be 1,800 feet. Okay. So AB is 1,800. 1,400 EB. BD was 700. And CD was 800. And these 2 have the same measure. Okay, so because we know that 2 of the angles are the same, right? That means the 3rd angle is also the same. That's true for any triangle. If 2 of the angles, right, are the same, 2 pairs of angles are the same, that means the 3rd pair is also the same. And because we know that these are similar triangles. Okay? Now, this angle is the same as that one, so we have to imagine in our head that it's flipped over, right? To imagine that it looks like this, for us to be able to visualize it properly. And so this 700, right, and this 1,400 are going to be a pair of similar sides that we want to examine, right? So in order to get from the 700 to 1,400, we multiply by 2. That means a common ratio for all the sides is going to be 2. So this 1,800 side, right, we're going to divide by 2 to get 900. And finally, this 800 side over here, we're going to multiply by 2 to get 1,600 over here, which is the side length that we want, and also our final answer. So it's important here to just realize that these triangles are similar because of vertical angles. All of the angles are the same, and then we just find out which ratio to look at. In this case, it's just multiplying everything by 2, and we can get this side pretty easily. Alright, next problem. Alright, so we see 2 triangles already. It's probably going to be a similar triangle problem. 2 triangles and vertical angles. Alright, so just like the last problem, vertical angles. This pattern appears a lot. When you see 2 triangles like this, there are always vertical angles right here. Right? So again, we see BD appears to correspond to BA, right? Because this side is longer than BC, just like BA is longer than BE. So it appears again as though we're going to multiply by 2 to get to the next thing. Let's just make sure that that's true first, and let's make sure that the triangles are similar. We only know one angle so far. In the figure above, AE is parallel to CD. Okay, now that we know this, it's an entire different ballgame. So, what we do is we extend the side out, like this, We'll extend this side out like this. Now, because we have parallel lines here, we have alternate interior angles right here. These two are congruent. Now again, if you need a refresher, when you have two parallel lines intersected by a different line, there are a couple of sets of angles that have the same exact value. There are these alternate interior angles. There's corresponding angles, right? Here 1 and 2 are the same. There's corresponding angles. 1 and 3 are also the same. And there's vertical angles. 1 and 4 are the same. In this case, your alternate interior angles, if you see it properly, this is the transversal line that's crossing through. You have alternate interior angles right here. And because these two are similar, that means this third one is also going to be similar. Which shows you that these two triangles are in fact similar. So now that you know the sides are the triangle similar, you look at the sides. The ratio is 2 again. What is the length of segment CE? Okay, so you know that BE is 8, so that means CB is going to be 4. So the entire thing from C to E is going to be 4 plus 8, which is 12. So again, using your angle knowledge, these are all of the angles that you need. In addition, you should also know that this makes a linear pair, right? When you have two angles that make up a straight line, they add up to 180. They're supplementary. That's what we call them. This, again, because it's on this line, right? The entire thing is going to be 180. Then we also have two more. We have same side interior angles, right? These two are also going to add up to 180. And yeah, I believe that's it. If you know all of these angles, you're perfectly fine, and you should be set to go. What is the length of segment C? Yeah, we got 12. Okay. So this is pretty important that you should know. And once you get this 7th angle, you also know that this 8th angle is going to be also congruent to the 7th one. So it's also going to be supplementary to angle 1. And let's look at this. The figure above, lines L and M are parallel. L and M. And then you draw the parallel line on. That signifies them being parallel. The measure of angle 1 is 35 degrees. What is the measure of angle 2? Alright. And S and T are parallel too. Okay. So let's go from L to M first, and then from M over. So we know that these are two parallel lines cut by transversal. So these two angles are corresponding angles. Just like here. They're in the same position, just like 1 and 3 were. They're in the same position. And since these both lines are parallel, they're going to have the same angle measure. So this angle is going to have the same measure as that angle. And then again, S and T are parallel, and they're cut by M. So we're going to do this corresponding angle over here. And then finally, this angle, we're just going to call it angle 1 and angle 2. Or sorry, we're going to call it angle 3 and angle 2 form a linear pair. So angle 3, which is equal to 35 degrees, by the way, plus angle 2 equals 180. So 35 plus angle 2 equals 180. So angle 2 equals 145 degrees. Once you get a hang of the different angles, these problems should get a lot easier. Again, if you have any questions, feel free to ask. Alright. Use a relationship between similarity, right triangles, and trigonometric ratios, and between sine, cosine of complementary angles. Alright. So, we know the basic ideas behind sine and cosine, but what's important to note is two special properties that you essentially need to know for the SAT about sine and cosine. You don't need to know all of the nitty-gritty details about trigonometry, all of the huge extensive formulas that they have. All you need to know is the complementarity of sine and cosine. So, these are the two things you need to remember. Sine of 90 minus x equals cosine of x. And cosine of 90 minus x equals sine of x. Right? These two things you need to know. Right? And we see sine of some angle equals cosine of another angle. Immediately, we should be thinking about these formulas. If sine of an angle is equal to cosine of another angle, that means they add up to 90. I follow one of these formulas, right? In this case, let's just take, for instance, that it's the first one, right? No matter what it is, 90 minus x plus x equals 90 degrees. So, at the end of the day, no matter what a and b might be, a plus b is going to equal 90. Whenever sine of an angle is equal to cosine of another angle, those two angles are going to add up to 90. You have to know that. It's a pretty important formula, pretty easy to use, pretty easy to remember. All you need to do is actually take the time and effort into memorizing it. You want to practice a couple problems with it just to get familiar with how to use it. But once you do, all you need to do is get to work. You substitute in the a, you substitute in the b for 90, or for a and b, sorry, equals 90. And then you get 10k minus 35 equals 90. 10k equals 125, and k equals 12.5. There we go. Alright. So pretty simple problem, not too bad. Again, if you don't entirely understand, don't worry. Just try and do some problems with cosine and sine being complementary. You'll get it pretty soon. Here we go. And this one is a much easier problem than the last one, about the same concept. In a right triangle, one angle measures x degrees, where sine of x equals 4 over 5. What is cosine of x, or 90 minus x? And again, sine of x equals cosine of 90 minus x. Keep this in mind, and this problem becomes so unbelievably easy. Once you know this, it's just 4 over 5 equals cosine of 90 minus x. And your answer is 4 over 5. Easy as that. This is how most of the problems for this section is going to look, but every once in a while you'll find a test that kind of makes you think about it. They give you that they're already equal, so you have to know that they're going to add up to 90. And then you just substitute some values in. But overall, this section shouldn't be too bad. Once you get the hang of it, of course. And again, if you have any questions, ask. Create or use an equation in two variables to solve a problem about a circle in the coordinate plane. And this should be our last section, actually. So for this, all you need to know is the equation of a circle in the coordinate plane. Just like you have the equation for a line, y equals mx plus b, there's the equation for a circle. And let me just explain it first before I go on to this problem. So for a circle coordinate plane, right, let's say it has its center is at h comma k, and it has a radius of, let's say, r. Okay, the equation for the circle is going to be x minus h squared plus y minus k squared equals r squared. This is always going to be the formula for your circle. Know this formula, know what it means. This first number is the x value for the center. Second, the y value for the center. Third, the square of the radius. You need to know this formula for the test. There'll be at least one or two problems about circles. And if you know this formula, they become so easy. You should be able to do them with these, without a doubt. Alright, now, which of the following is an equation of a circle in the xy plane with center 0, 4 and radius, the endpoint 4/3, 5? So it's saying you have your circle 0, 4, and it has a endpoint of 4/3, 5. So let's just try that really quick. So first we do the center, right? X minus 0 squared, so just x squared, plus y minus 4 squared, again just following the formula, equals r squared. We don't yet know what the radius is, but we will soon. All we need to do is do the distance formula, which is just another word for the Pythagorean theorem. So we know that this length is 4/3, and we know that it goes from 4 to 5, right? It goes from 0 to 4/3 for the x, so the length is 4/3. It goes from 4 to 5 for the y, so it's just 1. And so we know that this hypotenuse right now is going to be 1 squared plus 4/3 squared equals r squared. And it's important to note that we don't actually need the radius. We need the radius squared. So we don't have to take the square root after we get this radius. We can just leave it like that. So 1 plus 16/9 equals r squared. And we get 25, or I'm sorry, not 25. No, yeah, 25, sorry. 25/9 equals r squared. And that will be our final number. So which one has all of this? A. Plug this in here. Once you know the actual equation, this problem is just figuring out what the radius is. Pretty simple distance formula, aka the Pythagorean theorem. Alright, now again, they give you the equation of a circle and they ask you what the radius is. Now, it's important to note that you need to be familiar with completing the square in order to do this sometimes, right? Because in order to condense this into a simple equation, you need to complete the square. We have y squared, just like we did earlier. Equals -1. So we figure out what number we need to square by doing b/2. 4/2 equals just 2. So we square this, we get 4. X squared plus 4x plus 4 right? And we're going to add 4 to this side too. Then we do the same thing here, negative 2 over 2 equals negative 1 squared. So plus y squared minus 2y plus 1. Again, this is how you complete the square. If you didn't, or if you weren't watching earlier, to complete the square, you're looking to create the format x squared plus 2xy plus y squared. And in order to create this format, all you need to do is take whatever your b value is, divide by 2, then square it, add that to both sides. Do the same thing for this equation. Take your b value right here, negative 2, divide by 2, square it, add that part to both sides. You get 1. Right? And now you can simplify this into x plus 2, again, whatever this b value over 2 is, squared, plus y minus 1 squared. I recommend you get at least slightly familiar with completing a square. Again, you can ask me if you're not entirely sure about completing the square. I'll help you out with it. There's plenty of practice problems you can do online. I really do recommend doing at least some of them, because completing the square will likely be on 1 or 2 problems on your test, and it's always nice to be familiar with it. Alright, so now that we've gotten this, once we add the 4 and the 1 to this side, we get that the r squared is 4, so the radius is just going to be 2. Now that we're in our proper format, we know that the radius is just 2. Just like it is... Oh, did I not? Oh, I didn't even copy and paste the question. Oops. Just like it is up here. Alright, and I think that actually covers everything. So, using the information that I talked about in this video, again, you don't really have to watch everything that I talked about in this video. It's just whatever you need help with, whatever you don't exactly understand, you should just watch it. I'll go over a couple problems. Ask me about it later if you still need help. Try and go over other problems just by looking it up. But there's a couple, there's not too many major concepts that the SAT covers. As you can tell, I covered it in like 4 hours, right? It's just being able to intuitively figure out how to solve problems. Seeing, oh, I need to use this concept here. I need to use this concept here. Just being able to figure out how to solve problems. That is the hard part. Once you get that down, right, and that will only come with practice. Once you get that down, the SAT will be a breeze to you. Yep. All right. Thanks for watching.